Looks like we got another minute or so to go. People are showing up, so feel free to ask things if you'd like to ask them, or we can wait for everybody else to show up, or however you want to play it. This is your guys' time. I'm just here to answer questions or make suggestions or be suggested to, as the case may be.
So I meant to ask, Paul, do you have any presentation materials you want to put up? If not, I'll just turn it to a shared whiteboard.
None that I know of. Shared whiteboard sounds good. We'll as there might be some questions that for which a presentation would be appropriate, although I'd have to find the presentation and get it put in there. But let's burn that bridge after we drive off it, or however it goes.
Okay, we have a slight problem with the whiteboard and that I have no white slides. Bloody hell.
I could make one quickly if that would help.
Yeah, sure. Let me give you presenter anyway.
All right. Playing the file doesn't exist, which is like I'm trying to create it. Thank you. Thank you. That's awesome.
Well, don't spend too much time on it. You can start the BOF. I can probably find a white slide.
Okay. And I now have one. Just need to convert it to PDF and save it, or else actually I'll need to save it. I just need to convert it to PDF. All right, now let's see if it'll let me do this here. So we go to RC implementation BOF, and I edit the presentation materials, and I upload a file. I choose for my computer. I go up one level of directory, and I say whiteboard.pdf, and upload. And this may get the record of the smallest file. It's only 62.2K. All right, having done that, in theory, I should be able to hit share here somewhere. And I did this once already this year, so I should be able to find it quickly. Okay, you've got me marked as presenter, so that's good. Let's go over here, set status. That's not going to help me, right? Nope.
Would you like me to do it? Well, you can get on with the BOF. I can take presenter back.
I put it in the BOF presentation material, so please, I'm clearly not doing well this morning. Okay, so I think we've given the grace period required for people to show up. People show up in the middle, that's fine too. Happy to have them wherever. So I'm going to throw it out first for questions. Anybody have questions about RCU or issues, problems they're having, or things they'd like to see, or things they'd like to stop seeing, or whichever? Don't all talk at once now. I suppose I could stop being anonymous. Whether that helps or hurts, I don't know. But here I am. So
Well, everyone's shy, Paul. So there's a few questions coming in over the chat if you want to open the chat.
Maybe I should open up the chat, huh? Thank you. And it's doing this nice matrix spinning circle. And there we are. Okay, look at that. First question is no, but you actually verbally already. Wander Costa, please give an overview about the use cases of the different types of RCUs. And what's the difference between RCU and SRCU, which certainly fits in there. And which user space SCU installation I recommend. All right, okay. We got some good ones here. All right, good. So I'll take them in order. The different RCUs, I mean, if you'd have told me 25 years ago that there would be more than one flavor of RCU, I'm not sure what I would have said, but I know I would not have believed you. I wouldn't have seen the need for more than one. So let's go through in time order, I guess. Let's see here. Anyway, I guess I'll just, what I'll do is I'll type into the matrix chat as I'm talking, and that way there's a record of what I've said. Oh, we got a whiteboard now. Cool. Thank you. And can I do text and type at this thing somehow? Is that an option? I can do tools and I can do text. All right, look at that. So we'll go over here. So initially we just had RCU. As in, I guess I'll do the read side things, RCU read lock. And at that time, it was strictly non-preemptible. In fact, when the first preemptible kernels started appearing in the early 2000s, what RCU read lock did and recently does again, is do preempt disable. And so the thing is that if you saw a CPU context switch, you knew that any previous readers that CPU might have had going have ended. And that was the way it was. Then what happened was that a couple of guys in Norway, I think it was, and I'll remember their names at 3 a.m. tomorrow. Sorry, they came up with a scenario where you could have networking traffic so viciously intense that a given CPU never got out of soft IRQ, which meant that it never scheduled, which meant that RCU never saw a grace period end. And that was, so what happened was that we had RCU read BH, the BH flavor of RCU. The idea there is that this version of RCU disables soft IRQ across the read side critical section. And so any point in execution where soft IRQs are enabled, where you aren't in a local BH disable or you're not in a soft IRQ server, interrupts are enabled and so on, is a quiescent state. And that meant that even with a maximal networking load where you never got out of K-soft IRQD, it could still have quiescent states. And so there's some parts of networking that use that, again, for denial of service attack loads. As I mentioned earlier, the early preemptible kernels just had RC read lock disable preemption, and that was fine. If you want a few milliseconds of response time, it's great. But then the dash RT project started around 2004 or 2005, and those guys were looking for deep sub-millisecond response times. And at that point, disabling RCU across a task list walk just that killed you right there. So we needed to have preemptible RCU. I spent many months, many very depressing months, not finding solutions. Eventually, Esmond Nielsen made a suggestion that didn't work, but or it didn't work in general. It worked kind of in specific situations, and I was able to take and run with that and make the first version of preemptible RCU. But then you still needed non-preemptible RCU because by that time, people were using synchronized RCU or synchronized kernel, it was called earlier, to wait for interrupt handlers. So what ended up happening is we ended up with RCU read lock sched, which could just be preempt disable or IRQ disable or whatever, local IRQ disable or whatever. And so we had those three at that point for those different workloads. And up to about 2006, anytime anybody said, hey, I really need to block in an RCU read side critical section, that was a sign to me that they really didn't understand RCU and I needed to explain it to them. again until 2006, when some people came up with a real use case that really made sense. Fortunately, I'd already done preemptible RCU, and so at that point, I could see a way to make it work. Had they given me that use case before preemptible RCU, I probably said, sorry, can't help you. But that is where SRCU came from. Now, one question is, well, wait a minute, you got preemptible RCU, you got SRCU, what's the difference? And the difference is that preemptible RCU allows only preemption, okay? I mean, okay, if you acquire a dash RT spin lock, non-raw spin lock, which can sleep, that counts as preemption in a strange way. It's a special case because in those cases, there's priority boosting. So that means that somebody isn't running and the priority boosting will get them running. So it's kind of an indirect preemption, if you will. All right. All right, so SRCU, on the other hand, allows general sleeping, just sleeping any way you want. You want to wait for a network packet and wake up when the network packet arrives? Great, go for it. Might be a while, but that's your problem. And the problem is, now the first three were global, still are. In other words, if anybody anywhere does RC read lock, then any synchronized RCU anywhere will wait for all of those RC read locks to find their matching outermost RC read unlock. That fails miserably with SRCU because if you got somebody that has a little algorithm and they're waiting for a network packet, they're going to have really, really, really long grace periods. I mean, by design. And if you got somebody else that only wants to wait for disk transfers to complete, they're not going to be happy waiting for a network transfer that they don't care about. As a result, SRCU has domains. You create and initialize an SRCU struct or declare it statically. And each SRCU struct is its own thing. All right. So what happens is that each of them, the readers for a given SRCU struct, will delay the synchronized SRCUs for that SRCU struct and for no other one. So that's how we get away with having indefinite blocking, by allowing these to be gathered up into smaller chunks, so that somebody with long grace periods isn't inconveniencing somebody else that wants relatively short grace periods. Okay. And you could ask, I suppose, why not have domains or something for the normal RCU? And the reason is, if you have a situation where you can do it globally, that's much more efficient. With normal RCU, if you have a whole pile of synchronized RCUs showing up at once, you can do one grace period, a single grace period calculation, and satisfy them all. And that means the overhead of that grace period calculation gets amortized over all of those synchronized RCUs. And this is not subtle. It is really, really easy with a modest machine to end up with thousands of update requests, either call RCU or synchronize RCU or synchronize RCU expedited, for thousands of them to be satisfied with a single grace period computation, which amortizes the overhead of the grace period computation down to really close to zero and really helps the efficiency. Okay, so we got 4 of them so far. The next one, oh, this isn't very helpful. I wonder if I can make this a different size. Well, I'm not going to worry about it. I'll just start another box. So there. Okay. And the next one, I messed up by having readers. What I'll do is I'll put what will I put? Voluntary schedule, I guess. In other words, you weren't preempted, you scheduled, and that is that is a quiescence state. It delimits the reader in both cases. This was something that Stephen Rost had asked for, and it's used for tracing. They have trampolines, and the trampolines can be preempted, but they aren't supposed to have anything inside of them or anything they call that could voluntarily schedule. Okay. And so what happens is when they want to get rid of a trampoline because somebody removed a trace point, they update the binary so it no longer calls the trampoline. They wait for a synchronized RCU tasks to complete, or they use call RCU task, whichever. At that point, they know that all execution that might have been in that trampoline are going to return to that trampoline sometime in the future is complete, and then the grace period ends. These can have long grace periods, seconds. There's been some work to make them shorter by default in the normal case, but they can take a while, and that's supposed to be okay. All right. Then the BPF, next one was for the BPF guys. They needed to be able to attach helpers to both ends of a function that sleeps. A very few of them, that they're whitelisted. They have just a few that can do that. And RCU tasks didn't work for them, the voluntary schedule aspect. And none of the other ones. SRCU would work, sort of, but the overhead was excessive. BPF needs to be able to place itself in really, really high performance pieces of the kernel on fast paths. And the extra pair of memory barriers that SRCU has just meant it was out of the running. So we ended up with something that's kind of sort of like SRCU, but doesn't have the memory barriers. And that is RC read lock tasks. That's quite recent. That was put in last year, actually. There was another piece of the problem with the voluntary schedule of tasks is it doesn't catch idle tasks. And so what ended up happening in tracing is they had interesting combinations of SRCU and the RCU task voluntary schedule trick, and they also would go and just IPI all the they'd also go and force a schedule on all the CPUs. And so that ended up being open coded in several places. The thing saying, okay, run a task on each CPU, and this isn't like run the task on each CPU in turn. It's like for each CPU, wake up a task. And then when each of those tasks is run, wake me up. And that is, so that ends up being preemption, I guess, schedule anyway, however you schedule. And this is RCU task root. Root because it messes with all the CPUs, idle or not. There are also some other ad hoc uses of RCU. You can make use of work queues in an RC-like fashion. There's a few places that do that. And I'm probably forgetting something, but these are there's also a trivial RCU that's only an RCU torture, but I don't really count that because it's just there to verify my slides, not to verify anything that anybody uses in the kernel. All right, so those are 7. There's probably some other things that act like RCU, but that's a start. So Wander, I'm not sure how you pronounce your name. Does that cover it, or was there something specific you were looking for that I missed? Okay, great. Glad that was helpful. And then Ren, whose name I just mangled. Did that explain the SRCU RCU difference, or would you like me to dig more deeply into that? If you want me to dig more deeply, a more specific question would be helpful. While we're doing that, I'll go ahead to Nur Hussain's question about which. Great. Okay. Thank you. Glad it helped. About which user space RCU implementation I recommend. It depends. There's actually a lot of them by now. There is the one that Matthew and I, and Matthew's the main maintainer of it in user space RCU, and that one's good and sufficient. It could use some help. There's some things on my list to do to it for quite some time, mostly involving automatic update size scalability and performance, but it works, and there's a fair number of projects that use it, and it's been very heavily tested. There's also one in Facebook's Folly library that seems to work fine. It's C++ rather than C. There's Concurrency Toolkit, I believe is the name of it. There's a couple of other toolkits that have variants of RCU. They often call them EBR, or Epoch-Based Reclamation, which is a particular implementation of RCU. You have to be a little careful with EBR. The original paper presenting EBR as part of software transactional memory had a bug where it could get in trouble with preemption at the wrong place. But the ones I've looked at have fixed that bug, so they should be fine too. So the first question is, what language are you using? If you're using a garbage collected language, you have RCU already in the garbage collector. You're set, no problem. If you're using C, probably Matthew Denelai's user space library is probably the best thing for you. And that's in most distros in any case as well. If you're using C++, the Folly library, and there's a few other ones that are C++, I don't have a really good way of telling you which one you should do. And so I have to do something. Okay, so somebody told me that they're not seeing the updates. Apparently I have to click somewhere else to make the typing appear. Did that help, Claudio? If not, let me know. Sorry. I guess the trick is to type each one and then do another text window and type the next one. Okay, great. All right. So that's what I can tell you. Actually, what would be really cool is if somebody would go try them all and actually write something up. I'm probably not going to get to that. It's something that I would, in the perfect world, I would do, but there's only one of me, and there's a lot of demands on my time. So it'd be really cool if somebody would just go find them all, test them on various things, and give an overview of which does which, and which works better in which situation. Different situations, obviously different languages I've mentioned. There are also different trade-offs between scalability, whether you care more about readers, about updaters, and so on and so forth. Okay, Yun Levy, would you please share experiences about debugging memory barrier problems with ARCU? Oof, there'd be a lot of those. What I tend to do is be very conservative. And so I'm going to use heavier memory barriers and then weaken them carefully. And I'm going to use things like Linux kernel memory model for design to try to see if I've got something reasonable. For example, it turned out it wasn't something that, it turned out it didn't actually make things faster. RCU has hooks in the idle entry and exit code. And what those do is they increment a counter. They increment going in, they increment coming out. And that allows RCU to easily determine if some other CPU is idle. That's important because if you have an embedded processor, especially if you have a battery-powered embedded processor, it's considered extremely impolite to wake a CPU up unless you seriously have something that it needs to do. And it needs to do, not some other CPU that's already awake, can't do. And so doing something like saying, hey, CPU 5, are you going to quit the state? The CPU getting woken up, powered up, and burning a bunch of power, and then saying, oh, yeah, I'm not doing anything, and then going away is not a good thing. You can burn a surprisingly large fraction of the battery doing that sort of thing. And in fact, in the early 2000s, I was working on, I had one of the early prototypes of Dynatic idle implementation RCU. And what it would do is it would kind of run through the rest of the state machine. So it would invoke all the callbacks in that CPU and then let the CPU go completely idle, shut down the scheduling clock interrupt. So what would happen, a CPU would go idle, it'd be a few more scheduling clock interrupts, and then it'd be fully idle. So, what's the problem, right? Well, the people that were inconvenienced by that, flaming me on Linux kernel mailing list was not sufficient. They called me on the phone and they yelled at me. I kid you not. The phone rang, I picked it up, and there were people screaming at me for these extra scheduling clock interrupts. It turned out that those were worth 30 or 40% of their battery lifetime. And getting rid of those helped them out quite a bit. Of course, idle entry and exit is important. And we were asking about memory barriers. And the thing is that you have to sample this counter off CPU. I mean, the whole point is that the CPU goes idle and RCU doesn't make it do anything. And so that means some other CPU has to safely be able to sense that CPU's state, keeping in mind the CPU could wake up at any time. It could get an interrupt. It could get a wake up. Anything could happen. A timer might go off. And that means that you can't just kind of guess. It has to be very carefully synchronized. And so weakening those memory barriers, right? Initially, it was just an atomic increment. It has been for a long time because there was a feature that the MM guys thought they needed, but turned out they didn't. And so there were some extra bits and some potential updates. But it turned out they weren't using that, and they weren't. And so Joel Fernandez submitted a patch to remove it. I eventually applied that, and at that point, it's updated only by its own CPU. And at that point, you don't need an atomic increment. You can just increment it. But you need full memory barriers. And so I used the Linux kernel memory model to prove that I only needed a memory barrier on one side and not the other. I could use a store release and a load acquire to get the ordering in the other direction. Frederick Weisbecker believes that I can get rid of one of the remaining memory barriers. And he might be right, but he's going to have to prove it to me. But the problem was, so what happened is you have a non-atomic increment and a full memory barrier, SVMB. The problem was that full memory barrier on x86 is, guess what? It's an atomic increment. And that meant that by making it more efficient, I was actually making it less efficient on x86. Linus noted that and says, I'm not taking that patch. We were still able to get some reduction in overhead on the read side. So we got something anyway. But it's an open question whether I can make that more aggressive, reduce it. So to tie that back around, what I try to do is avoid debugging. I try really, really hard to avoid debugging memory barrier problems. And the way I do that is I use stronger memory barriers unless I can absolutely prove I use weaker ones. And I do the initial debugging with the stronger ones and weaken them very carefully afterwards. The reason for that is it's really easy to make a design where you have a weaker memory barrier. And then later on in the middle of debugging, realize your design wasn't quite right. So you adjust your design and do something really simple that means, hey, wait, no, I need stronger memory barriers there, and not realize it, okay? So it's better to get the thing working and then weaken than to try to weaken to start with, unless you've got something that's so straightforward that you just use, for example, store release and load acquire and know you're good. So that's one example. Maybe not quite what you're looking for, but that is my advice. If you're doing code that is lockless, use the strong synchronization first and weaken it carefully. And the reason is you do not want to be debugging ordering and your algorithm at the same time. So debug your algorithm thoroughly and then do the ordering. It's good. Now, don't get me wrong. You want to think about the ordering ahead of time. Because if you wait until afterwards to think about the ordering, you've probably designed yourself out of the weaker models. But be careful. Stick with the full memory barrier and perhaps load acquire and store release in cases where they work straightforwardly, okay, where you're just communicating from one to another. That's my advice. There's probably better ways to do it, but we've all got something to learn, right? So Dimitri asks, do I have any ideas how RCU can be improved or extended, or any future work ideas for RCU? Actually, I've got a list that's kind of long. There's a fair number of things involving RCU torture, for example. In fact, there was a suggestion yesterday that I have some way of overcommitting CPUs to more aggressively turn out bugs. That might be a good idea, might not, but it's worth thinking about. I should add it to the list. There are any number of things. For example, right now in preferable RCU, RCU relock and RCU unlock involve a real function call. There's really a call involved, whereas in non-preferable RCU, it's an inline function, static inline function. So there's no function call instruction. Lai Zhangshan some years ago gave some patches, a patch series that got it to where on x86 it could be also an inline function. The reason that it's hard to make it an inline function right now is that it accesses a field in the task structure. And the task structure isn't available everywhere. And if you try to make it available everywhere, you end up with all sorts of problems with include file cycles and issues. What Lai Zhangshan did was kind of a clever trick involving making it so that it didn't have to live in the task structure. But that also had the effect of having some more stuff happening on context switch. So at some point, I need to take the scheduling guys aside and say, yeah, come on, I haven't heard complaints, specific complaints about people, aside from Lajong Sean sending the patch, saying they're running into problems with overhead on that side. I'm sympathetic because I mean, you got an extra function call that can't be free. Linus one time complained about it, but it turned out that that was a problem with his measurement, and so he retracted the bug report shortly thereafter. But at this point, there is an overhead. One of the things I've been toying with for a long time, in fact, there was a patch I might have been submitted. I can't remember who submitted. It might have been me, where we just had a build step that calculated the offset in the task structure and made that available elsewise. And people got rather upset with that trickery. But that would have the nice effect of not requiring the schedule to do anything extra and allowing us to have inline functions. So that's a couple of examples. There's a lot of things like that. Let's see if well, let me just take a quick look here, see if there's anything of interest on my list. Let's see here. Block torture could use some help. There's some a bunch of things on KV free that that Vlad is working on. Miraj and I have been going through task trace RC, which is fairly new. He found some bugs and provided some fixes, as did I. So that should make that better. That's just debugging though. One question I have for you guys: there's this thing called config fast no hertz. All the places I know of where people use it, it's useless. Okay, so what's config fast no hertz? What it is a thing that allows you to enter idle more quickly. Okay, and so embedded people have liked it and used it, except that all the embedded people I know that use it right now also offload all their callbacks. Well, if your callbacks are all offloaded, fast no hertz is doing nothing for you. It's adding overhead to the idle transition. It's adding a check. Hey, am I offloaded? Yep, I am. Okay, don't do anything. So from what I know right now, I should remove config RCU fast no hertz. In fact, I'm gonna type that because I think that's important. And one of the I've had on my list for a while, and I just haven't gotten to it. I'm going to submit a patch that removes it, and if nobody complains, it's gone. So far, all the people that I know have been using it have been using it in a way that isn't useful. So that's one. So thank you. That was something I should have mentioned to begin with, just because I'm curious. Let's see. One possibility that's been batted back and forth, I don't know if we'll do it. Right now, I mentioned that RCU can remotely sense whether a CPU is idle. A CPU can be idle from an RCU perspective in two ways. It can be in the idle loop, deep in the idle loop with Peter's changes of a year or so ago, or it can be in no hertz full user space mode. In other words, there's only one task, it's in user mode, nothing else is happening on that CPU, and so there's no RCU happening either, and we don't want to interrupt the CPU. And right now, those look the same from RCU's viewpoint. Should they look different? And there's some possibility that some parts of the kernel could use an indication of whether you're in no hertz full in one user space on the one hand, or deep in the idle loop in the other. So that's another possibility. There's, as I said, a bunch of testing things. There's one of the things that I've been working on for a while, and I've made some progress, but more is needed, and that's dealing with cases where callbacks are flooded. And to Shaquille's answer, it's RCU fast no hertz, but you need config in front of it. Config won't fit, so there you are. But yes, please check. If somebody's using it and they need it, I shouldn't remove it. But if nobody's using it, let's make it simpler, right? Anyway, there's some really simple ways you can flood callbacks. One is just have a loop in user space where you open a file and close it immediately in a tight loop. And every pass of the loop generates an RCU callback. You can generate a rather large number of them. And RCU can keep up with that. But there's a possibility of other things. Now, if you do that inside the kernel, I'm going to tell you not to do it. But user space does what user space does. And if you're doing it in the kernel, come on, put a con resket or something in that loop so that we have a chance. Thank you. So that's a few things. If you're interested, I can make a more complete list, and a lot of it's speculative. You know, I get an idea, write it down, and it may be that I just never do it. It may be that it's suddenly becomes really important and I do it, or I may do it because I think it's cool or something. I don't know. I'm less inclined to use the last reason that I get older for some reason. Okay, let's see here. Kumar, what do you think of the new user interrupts in x86? Send you IPI in the context of signal M-barrier-based URCU flavors. You know, that's really a question for Matthew, and he's on this call. So if he's up for it, I'd ask him to answer. Matthew, you willing to take that on?
Can you just restate the question? Which one is it?
The question is, what do you think of the new user interrupts in x86? Send UIPI in the context of signal membarrier-based URCU flavors.
I'd have to look more in details into it to have an informed opinion.
Okay, same here. But Kumar, could you send Matthew and myself an email pointing us, describing what you think, how you think it might be useful? And the question, Shaquille, it's Kumar Kartikeya Duvidi, whose name I probably just mangled, the green K. Well, maybe different colors to different people. The guy that just said sure down here. Thank you, Kumar. Look forward to getting the email. And that's where the question is. Okay, let's see here. And we see on Matthew responding, saying it's recently improved. So if you do a test, if somebody does a test comparing things, please make sure you talk to Matthew and make sure you're getting the latest and greatest stuff. You know, rather than just grabbing whatever your distro might happen to have, which could be quite old. Matthew also noted that there's a C API, but it can use C++, and that's great. The difference, what Folly is actually integrated in C++, so it knows about templates. So you can, so instead of having an RCU struct you put in your structure, you inherit from, I can't remember the name in Folly library, and the C standard is RCU opt base. Why that makes a difference is an interesting question, but there you have it. Okay, Matthew asks about an extension, RCU lock, kmalloc, GPF kernel, if RCU needs to require a lock. Okay, well, if you do, I'm not sure exactly what you're saying there, Matthew. I'm gonna take you very literally initially, and then tell me where I went wrong. If you do RCU read lock, then kmalloc had better say GPF atomic, because we don't block. So
right.
help me out.
So what I'm asking for here is the ability to auto-magically drop the RCU read lock. So it wouldn't you wouldn't want to just call RCU read lock. You'd want to call RCU read lock auto drop is okay, and then generally when you call kmalloc, you don't need to drop the lock. But we do all these games right now where we either allocate memory up front when we won't necessarily need to actually use it, or we use GFP atomic when actually it'd be fine to sleep, but we don't want to write the code to yeah, it's awkward, right? So I want to say it's okay to automatically drop the RCU read lock. I will check before I do anything else that was being protected by the RCU read lock.
Okay, so I'm a little concerned about this because I see it as a potential way of generating all sorts of bugs. So I think there'd have to be a lot of work on how to make something that that would be safe in this case. I'll throw out a possibility that I don't like, but maybe it'll, I mean, well, first off, I'll start off with one I do like, which is, okay, well, explicitly get out of the read side critical section when calling kmalloc and get back in, and then know in your design that that's what you're doing. The thing I'm concerned about is that some guy does a read side critical section, calls something that does this, where he needs the critical section to extend over there, and he passed the wrong GPF flags. I want him to be yelled at, right? And he probably does too, right? I mean, it's a lot better getting, I mean, it's really irritating getting locked-up complaints out of RCU, but it's, in my opinion, a lot more irritating to have a really weird RCU bug where your stuff's getting freed out from under you. So how can we, okay, so what you said was you wanted an RCU read lock we can drop out momentarily. The thing I'm concerned about is that you usually, in that case, would have specific areas where it was okay to drop out. And then how do you tell whether you're in one of those areas? The way I like is to say RCU read unlock. RCU read unlock is pretty cheap, and so is RCU read lock. They're especially in non-preemptible kernels, they're they don't emit instructions. I mean, they constrain the compiler thanks to device drivers and page faults, but they're pretty cheap. So why not just get out and come back in? Yeah, unconditionally. We got a 5-minute warning because we got some other people coming up. Why don't we? I think what we need, Matthew, is more than we're going to be able to discuss in 5 minutes. I think we need to discuss and look at an actual use case and see what works best in that case. I'll tell you I'm skeptical, but you know I've been skeptical. I was skeptical of SRCU to start with too, so who knows, right? All right, let's see. Goren, is RCU torture testing CPU memory consistency enough for RCU RTL black box testing? What's the suggestion on memory consistency by Linux test? K-litmus, RCU torture, lock torture. So let me restate what I think the question is. I think what you're asking is, hey, I'm making a new CPU. What do I do to make sure that I've got that I don't have hardware errors in the memory ordering? Is that fair, or am I on the wrong track?
Yeah, that's what I asked, and I want to, you know, the CPU RTL design, they will have a DV design progress and just proved by the RTL code by the hardware engineer by themselves. But when they integrate the whole CPU to us, we will test. And firstly, we will check the memory consistency is right or not. And the second, we will to check that the stable or one strong a high pressure on the CPU running for some lockless and a lot of acquire release spin lock gathering together and to see the CPU would cause some problem or not.
Okay.
Yeah.
So you mentioned K-litmus, and Bouchon seconded that. However, to your point you raised about high load, I suggest you run K-litmus with a heavy background load as well. Okay. So K-litmus is a facility, and litmus, just straight litmus. K-litmus creates kernel modules which run in kernel space. There's also litmus 7 in the herd tools toolbox, and I'll type that.
Yeah, I know.
Okay, great.
Yeah, I know K-litmus. Litmus just
no, but not K-litmus, but also just litmus by itself. Okay. Yeah. And we got a 3-minute warning. Thank you, James. And the thing you have to worry about is making sure that you have the right set of litmus tests. What I know some people that do this, they may or may not be willing to talk to you. What I can do, send me an email and I will contact them. And also tell me, if you can, what CPU you're working on. That may make a difference. And I'll contact them and see if they're willing to talk to you. I can't make any promises, but I can promise to reach out to people who do that and have done that for years, using tools like Litmus. Okay, and perhaps that'll help. Fair enough?
Yeah.
Okay, if
I
that works
just,
for you, send me an email.
Okay.
All
I
right.
will send you an email.
Let's see here. Main problem, URCU applications are not making progress. Yeah, Dimitri, that is a problem. And that's the reason there's multiple flavors of user space RCU. And fortunately, there's been some progress that Matthew would be better able to talk to, but we don't have time, that makes that less of a problem. And then Claudia, you've got a good question. I do not have time to answer it. I'm sorry. Send me email and we'll go from there. I'm sorry, I can't do that. I can't talk about non-determinism in 1 minute. So with that, I think we're done here. Thank you very much for all the questions and comments. And so I've had several people to get back to me. Let's keep the conversation going via email and other things. Thank you all very much and have a great rest of the conference. And thank you, James.
Okay, next up is Liam Howlett. Do you have any presentation materials, or shall I just leave the whiteboard up? I can clear it. It would actually help if you were in the room. Matthew,
Yeah,
can you get
no, I'm here. Yeah, no, just clear the whiteboard. I don't have anything to present. Thank you. Yes. So I wanted to go over, schedule this because it's, I guess, LFS and stuff canceled and all, and we don't really have much time to talk about the VMA life cycle and where we kind of want to drive this sort of thing. There's been a lot of questions about how we're going to handle locking with the maple tree, and there's also the speculative page fault stuff that Michelle's been working on. I hope Michelle's here. Scrolling through, yeah.
I'm around.
All right, great. So I just wanted to have something where we can discuss kind of the overview of what we're trying to do and how we're trying to go about it. So the main purpose is we want to get rid of that lock contention in the mmap block. So I did have a talk a couple days ago, brief as it was, but basically what we were looking at trying to do is to take things to get an RCU tree in to track the VMAs, and then when we get the VMAs tracked in an RCU tree, we can start pulling out readers from the mmap block and slowly remove things so that it's no longer such a big contention. For this to work, the VMA lifecycle kind of has to be shifted from what we have now. For people who are not familiar with what it does, the VMAs, they kind of live for a long time. And what we see libraries doing is they map everything and then they just kind of chunk it up. But when they get split up, the VMA that was originally the big one will eventually become a smaller one by the fact that every time they split it, they keep we keep it around, and we kind of have to get rid of the RB tree for RCU to work, because the RB tree can't be updated in an RCU free way, RCU safe way, and that's because the way that the tree works is that to update the tree, first you must remove the VMA from the tree and then re-add it, and in doing so you can't be, I mean your readers kind of hosed there because they'll not see what they're looking for. So we need a way that we can juggle the VMAs around so that we can allow readers to always see at least a consistent if not consistent, but a detectable way to tell them to restart. And so what we've been throwing around is this idea of VMAs cannot shrink. They always grow. So if you have a reader that's there and they take a VMA, as long as the VMA is still around, then you know that the area that the VMA covered is at least still covered by what it took the page fault for, or whatever reason the reader has the VMA for. So that was one of the things. And then the other things, we wanted to make the VMAs freeable. And we came to the conclusion that if we do this, then with the other locks in play, what are the other locks? I had it on my, the file lock IMAP, I believe, and the anonymous mess.
Right.
The very complicated anonymous tree. So those two locks, when the VMAs are being changed, the first thing that happens is the mmap lock is taken, and then the other locks are taken, and the VMA is taken out of those trees as well. I believe those are interval trees, right?
Yes.
At least one of them is. I'm not sure about the anonymous. Yeah, you changed them both. Yeah. So yeah, when we're trying to figure this out, we looked at how that's happening. We said, well, we need a way to tell the readers that there's something going on here. So they find their VMA and they want to use it or whatever. Then how do we stop them from doing something something that'll cause a problem? And we kind of thought we'd add a flag, a VMA flag, which there's very little space for, but now there is. So that's great. So we were talking about basically an inactive flag. So if you're going to be changing the VMA or whatever, you can flag it as inactive, and then as readers come down, they see the inactive flag, they'll restart until it's done. It shouldn't be a long time. They could busy wait, or they could reschedule themselves depending on the reader. So that's kind of what we were looking at, and that's sort of what I was trying to get at, hoping to get at in my talk before there was technical difficulties, and we kind of ran out of time anyways. So that's kind of what I wanted to talk about here. And the other thing I wanted to talk about is, Michelle, how this fits into your SPF work,
Right.
and if we can land it in a way that we don't make a huge change in the same area, very close to each other.
So, yeah, there are different problems there. If you go about the problem of RMAP updates, we do have the problem that to update RMAP also cares about merging adjacent VMAs and that sort of stuff. And that right now that's done atomically with the work on the RB3. So I think in the end you will need, I think in the end you do need that sort of atomicity of updating the two together, which means you need a lock that protects both. And I think that lock cannot be a spin lock because RMAP uses sleeping locks. And so I think you still end up needing something like the mmap lock around it all somehow.
So how does the RMAP locks, when we get into the so how does it work today? Today we take the mmap lock, we go and we find our VMA. How does RMAP do it?
So RMAP piggy. So right now we take the RMAP lock, we update the VMAs for the current address space, looking them up in the RB tree. And whenever we update one VMA we found in the RB tree, we update the corresponding information in AirMap, because
So
these VMAs are also in AirMap. So
but it
if we
gets
merge
taken out,
two,
right? It's taken out of that tree for the update. Yeah, you have like the RMAP. So RMAP is the anon VMA, and there's an anon VMA pre and post, right? And one takes it out, and then the other one takes it in. So or puts it back in. So you take it out of the tree, and you take any of the VMAs out of that tree that are going to be affected, and then you re-add them later, right?
I do not remember the implementation details, but what it comes down to is if, for example, we split a VMA or we merge with an adjacent VMA. So we look in the current address space what we do with these VMAs, right? We might do splitting, merging, and all these VMAs we touch, we update in their corresponding arbitrary. Yes, we probably take them off and put them back, but that's kind of a detail.
Yeah, no, but you take them out of the other tree. It's taken out of the RMAP as well, right?
Yes.
Right. So when you take them out, how is that? What happens if someone is searching for that while it's out? It's contended on the mmapsm?
They won't see it because we only take them out while having the proper RMAP lock. Like there's a couple RMAP locks depending if it's an anon VMA or a file or whatever. But so they won't see it. If there's a lookup, they will use the corresponding lock, and they will not see our temporary state where we removed it, which is why I see it as a complete implementation detail.
Well, so if they won't see it, so I'm failing.
What they will see is that, so before in RMAP, maybe we had two VMAs, and if we merge them after in RMAP, we have one VMA.
Yes.
And that's the update we need to do. So if we try to protect VMAs only with the Maple tree lock, which would be a spin lock, we can't update RMAP at the same time under that lock, because RMAP, because to update RMAP, we need to take the RMAP locks, which are sleeping locks. And so we end up having to do this work of saying, well, now we had one VMA and now we have two. And how do we find out that we have two if we broke the atomicity with regard to the VMA tree update, like, to the RB tree update or Maple tree update, whatever.
Okay, so you have. I still don't see the race.
So in the VMA tree, let's just pretend we merge two VMAs, okay?
Okay.
So in the VMA tree, it's easy to see because we see the next VMA is adjacent to us, so it's really like the next VMA in the tree, and that's how we find it and we merge it. In RMAP, they will not be adjacent because there's multiple address space, that like for that file in RMAP. So they will not be adjacent entries in the RMAP interval tree. And so right now, the only way we find that these two VMAs are now one is because we did the work in the VMA tree.
Okay. I don't really. Okay. Yeah, I don't know enough about the RMAP to say whether or not whether or not we can get around that. Hmm. Okay. Gonna have to look into it, I guess. The way that I saw it working was the lookup in the RMAP tree of okay, so the VMA would be marked as inactive, so you know something is happening. It gets taken out of the RMAP the RMAP for the pre-update, and we do our work on the VMA, and then we reinsert it. If you're going to be merging, then you have to take those out as well of the RMAP tree, and do the same VMA work. So I don't see a problem with the locking, but maybe there's a race somewhere, because basically you would change the VMAs as inactive, which doesn't need a lock. Then you would go and you would take the VMAs out of the one tree, and you would do you would make a new VMA, put it back into the VMA tree, and then back into the RMAP tree. And you're saying that won't work because of I'm not really sure why you're saying that won't work.
So right now, RMAP doesn't have these inactive VMAs or anything, right? So right now, people, like, if you do anything that goes through RMAP, right, it will take a look and find what's in RMAP for a given address, and
it's sleepable, so a retry won't work. Is that what you're saying?
and it's sleepable. I don't know if a retry would work, but it.
Okay, so that's definitely something we'd have to look into, to make sure that retries on RMAP for sure, and that's not somewhere we've gotten to yet on the non-shrinkable VMA front. Essentially, what we're looking to do is reverse the locking, so that first of all, readers no longer take the MAP lock at all, and second of all, the writers that need to write to the VMA tree take the lock for a much shorter amount of time, and that would be in that update window where we create the VMAs and just write it in to our tree, just swapping it in, so that basically the RMAP's locks are before the VMA lock, and since the readers are already out of the way, the VMA lock would be only contended on writers only. So I feel like that would be it would greatly reduce the time spent writing to the tree. So basically what we're trying to do with the VMA lifecycle is change it from constantly having it and splitting it up to just creating new ones if you're going to make smaller VMAs. And readers that need to sleep
So
could potentially sleep as well.
the thing is, when you do that, it's not just a change that's local to the VMA tree. Like, if you're gonna recycle your VMAs that way and get rid of the old one, put a new one instead, you have to do the same change in the RMAP tree, and so that makes it a bit complicated.
Okay, so what about the RMAP tree do you need to do that for? How does the RMAP tree function differently? I mean, it comes out of the tree already now, right? Like there's a pre-update that pulls it out, and then you put it back in after you did the change. So what why does it matter if it's a new VMA or not?
It's fine. It's a new VMA. You just need to update it in the AMAP tree as well as in the RB tree.
Right. So we essentially we would be inserting a new VMA as opposed to the old VMA.
Yes.
I actually don't really get how that works now. When we split, the RMAP tree keeps the giant VMA in there. So they must. I don't really get how it gets decreased, and I've asked a few times, and nobody could tell me. Does anybody know how that works? Like if I have a VMA and I split a VMA, it gets taken out of the RMAP tree, but whatever's behind that VMA, I don't get how that's managed. Like where does the pages get trimmed on the anon VMA once you split it? I don't really, I guess nobody really here can answer it, or nobody's listening.
Not out of the top of my head. It's every
But you know
time
what
I
I'm
look at AMAP, I have to take several days to page it back in.
Yeah, it's a complicated thing.
Yeah.
Okay. The other thing about the I guess is the file
SPF
backed. Do you see an issue there at all?
for the file side,
Yeah.
I think it's exactly the same as the anon side. It's probably a bit simpler, but like you're probably better off looking at the file side than the anon side. Anon side has some extra complications on top that are not really relevant to, like, the difference is not important.
Okay.
Because
Okay.
Anon has the thing about, like, if you fork multiple times and blah, 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 which doesn't exist for files. So
Yeah, same and shared or something, the two chains. That's what you're talking about?
yeah.
Yeah. Yeah, it's a
Ignore that. That's not relevant to your problem. Just look at the file thing. If you make the file thing, the Anon thing will work too.
okay. Okay. And then the other thing is the changes to the forking. I don't think there's an issue there either. Basically take the lock and copy the tree and then drop the old lock.
Yeah, I think that's fine.
Yeah, that shouldn't be an issue, I don't think. And so the SPF stuff. So you're changing. You want to change the locks as well for that, right?
So for SPF, so I don't like the part when you're talking about having ref counts for VMAs, that ref counts that really are locks, in the sense that you might have to block on them, and that's still an unprecise thing, and blah, blah, blah. Unprecise in the sense that you might end up blocking because there's a patrol that took a ref count on a VMA, and there's someone trying to write on a different part of that VMA, but it doesn't know. The only thing we know about the page is that it took a ref count, so we don't know where it's exactly working. And so my preferred way to deal with that would be to make SPF actually work, in the sense that we would want SPF like instead of taking a ref count to prevent vitals, we would want to have the page fault not prevent vitals, and have a reliable way to check at the end if there was a vital that actually interfered with it.
Okay, so I was thinking, so first off, for people who are listening, the ref count on the VMA it goes with the inactive thing, because or the RCU version, because when you get a VMA, if you want to make sure that VMA stays around for some reason, then you can increment the ref count on the VMA was the idea. My thoughts on the oh, go ahead, Matthew.
Sorry, that's just
no.
Okay, so we could actually do without adding a ref count to the VMA, I think. So the reason we have the ref count on the VMA in our architecture is that we've hit a slow path, right? We have got to the point where we realize we're going to need to call into a file system or a device driver in order to handle a page fault, and that code might well sleep, and you can't sleep while holding the RCU read log. Right. So the idea was to take a ref count on the VMA, drop the RCU read log, call the fault handler. Okay, thanks, James.
And so, yes, you're gonna call into file system code. You do need a reference on the file, which right now you get through the VMA.
That's right. So what we could do instead is what the horrible hack we have in filemap.c does right now, which is to take a ref count on the struct file, and that pins everything that needs to stay pinned. Yeah, so we need to go back and unlock the and look up the VMA again, but I mean it's slow path, so who cares?
Yeah, well, the ref count is it's a time savings, right? Maybe we could find some other way of doing it.
So
might be more efficient than just restart.
Well, in my current patchet, I have an unprecise check, right? That's based on just a vital sequence count. You can have a precise check behind an unprecise one. You could have, check was there any vital? If there wasn't, you're done. If there was a vital, now you want to know if it interfered with you, and so you could look into doing it that way.
We could do, but I mean, we still need to go back and look up the VMA again.
Only if there was a vital.
So you would have the version, the whole tree, I think, and at that point, it's the whole memory space potential modification, any modification on the memory space, right? Like it.
Right.
I mean, I'd rather go and look up the VMA again, to be honest.
Yeah.
That's
Yeah.
fine too.
Yeah, especially with RCU. I mean, they keep it RCU safe. What do you do with the ref? It's an added complexity. The sequence counter on your sorry, I was reading James's comment. The sequence counter on your speculative page faults. I'm under the impression, and I wanted to clarify that if a speculative page fault, hold on, if there's any activity in the VMA or in the area, then it will it'll throw out the work. Is that right?
So in my current patchet, you mean?
Yeah.
Yes. So I just have. So yes, what I have right now, I have an imprecise check. I do not try to prevent vitals. and if there's any vitor at all that happens during my speculative fault, at the end it will abort. It doesn't try to find if that vitor interfered with that specific fault or not. It just has an imprecise check. Now, the reason it works okay is that in the path, in the common path, the fault is probably very fast and usually will not frequently have a vitor that interferes. If there's a vitor that interferes, usually that's because the fault had to allocate memory and reclaim and do something slow. And that work that it did is not really wasted, because in the end, we probably would have to have reclaimed memory anyway. So it kind of works in, it's imprecise, it's not great, but the work it does is not completely wasted. We probably needed to reclaim memory anyway. So that's kind of how it works in that tree. It's not great.
Yeah, well, I mean, I think my only concern about it is when you take a speculative page fault, if there's writer contention, then the speculative page fault will almost always fail, which means you will be burning more CPU when there is contention on the mmap semaphore. Is that an accurate statement?
Yes. It's just
Okay.
the work we do in the speculative page fault usually won't be completely wasted because it did reclaim a page, or whatever. It did allocate a page, which usually, if it was expensive, that was because of reclaim. And
Yeah, so it's not that expensive anyways, and the trade-off is, for the most part, you're getting faulted in pages that you actually want.
yes.
Okay. Yeah, I was talking to Vlasmil about it on RC, and we weren't sure on that point. Okay.
I do think it would be better to make it precise. It's just hard to make it precise in all cases. The hard case is the copy and write case. So if during the page fault we end up copy and writing something, right now the copy is protected because we know the original page is read-only and will stay read-only while we copy it. But if we allow writers to proceed in parallel with us, they may write into the page we're copying, and the PT might end up being the same at the end of it all when we check it. Like the VMA, the PT might be back to read-only when we check it at the end.
Yeah. And your check is on flags and the addresses and stuff, or is that just the sequence?
I check the sequence. So
Yeah.
I just do the simple check. So
And
if
it's
there's
an-
any vital at all, I abort. And
it's an odd even, right? Yeah, if I
Yes.
recall.
Odd means that there is currently a writer. If it's higher than when you started, it means somebody has at least started writing to it. They might not have finished making a change yet, but the tree is notionally out of date.
Yes.
And those sequence, that's a tree wide? No, it's an MM wide.
Yes.
Yeah. I'm just trying to figure how it will fit into the maple tree. If
I don't think it does. At least my mental model of how this is all going to work doesn't include a sequence counter or a sequence lock.
yeah, well, if you're just doing it on updates, can it work together? Can it? I think it's okay if the maple tree does nothing with the sequence lock, and it's just used for the speculative page faults, then basically the mmap write would take the mass lock, lock the maple tree and increment the sequence counter, or vice versa. And then continue on, and then when you unlock, the same sort of thing. Do you see an incompatibility, Matthew?
Yes. I'm really confused why we see. I see SPF as being some of the benefits of what we're doing, but not all of them. So if we convert over to doing everything the Maple Tree way, I don't understand what SPF would get us.
I think basically what would happen is the pages backing the VMAs will be loaded before somebody looks up the VMA would be the goal.
The part I'm trying to avoid is when you have a page fault that would somehow mark the entire VMA as having a read going on in there. And then that prevents you from having a writer change any part of that VMA because you don't know if that actually interferes with that fault or not. So that's the part I'm not happy with, that I'm trying to find a way around.
Okay, so I think we can change our locking to locking. Reference count / locking / everything else scheme to do that, because we don't need to take a ref count on the VMA. I was thinking that taking a ref count on the VMA was better than taking a ref count on the file, just from a cross CPU contention point of view. But perhaps that's just over optimization. We don't need to do that. It makes everything else too hard. So perhaps just drop that and go back to taking ref count on the file. I'm okay with that.
If you don't actually block a writer working somewhere else, then I'm okay with it. I'm not set on speculative or whatever. Like as long as you don't have that false conflict, I think that's great.
Okay. I will think about this some more, but I don't see a reason to not just do this with a file ref count at this point. I'll keep thinking about it.
Thanks.
Thank you.
In the past, one issue that has happened there is people who do weird thing, and it's usually tests that may, in the end, unmap that VMA, even in a racy way, and then try to unmount the file system. And so at that point, they will see an active file ref count, and what do we do with it? How long do we like? So I don't have a solution to that. And even doing things like RCU can trigger this test, like they do whatever they do, and then they want to unmount, and they're still within the RCU grace period, so they cannot unmount right away. So if they don't have races, just waiting one RCU grace period could, get around that. But if they actually do racy things that we take file ref counts for, then how the hell are we gonna handle that? I don't know. I think it would be just fine to tell them busy if they actually try to fault why they why they unmount that VMA, why they unmap that VMA. They have a race, the thing is actually busy, sorry, whatever, we don't support you. I don't know, but it's gonna show up in that covert way.
So you're saying you're unmapping a VMA that is currently being read somewhere? Is that?
Yes, there are tests doing weird shit, and I think including that. And so
they
cannot unmap that VMA because of the page fault, so that will synchronize it.
I
think I understand what you're saying, and if I'm right, then we're not vulnerable to it. So let me just say what I think you said, and then explain why we're not vulnerable to it. So what you're saying is that under some circumstances, there can be a reference count held by a VMA, which is only released at the end of an RCU grace period. And so if you try to unmount during that RCU grace period, the file system is going to be busy because we've got to wait for the end of that grace period until the VMA drops its ref count.
Yes, and we did see issues with that just when I was trying to handle files in my SPF patchet by deferring freeing of VMAs. And that triggered that whatever these tests are doing.
Yeah, so I think the design we currently have does not hold a reference count across an RCU grace period. So when it's freeing, am I wrong?
No, it doesn't. No, you're wrong.
Okay.
Sorry.
So the RCU grace period is only to free the memory of the VMA. The VMA drops its reference to the file at freeing time, and then RCU delays the releasing of the memory that the VMA consumes.
Yes. You were just talking of taking the file reference during the page fault.
That's correct. Yes.
And the possible ways is that someone could try to unmap that thing while the page fault's going, which I'm arguing we should not protect against because we don't know where the fault's occurring. But no, after they do that, after they unmap that VMA, they could also try to unmount the file system, and they're gonna race with your fault happening in the background.
Okay,
So
but that's
reading.
hang on. So that would be them trying to unmount a file system while there's actually I/O going on to that file.
Yes, I agree. Just
that should be easy.
How come there's I/O if I was able to unmap my VMA, and there's still I/O going on into it, right? That's the confusion they will have.
Okay, yeah. So the unmap today would block until the fault are completed, but we're actually just going to unmap even though the fault is ongoing. That's an interesting point.
I would be ready to argue that it's their own downfall for doing something racy and that I don't care, but I don't know if people will object to that.
So like you press the eject button on some device and it's, or you're pulling your USB stick out really slowly, or like, I don't. Isn't the issue you have to protect the VMA from being deleted while the fault handler is running? Because the fault handler probably relies on the private data memory.
I'd like to thank our device driver expert for speaking up at this point.
Fault handlers.
Yeah, Jason's right. We actually need to protect. We do need to prevent the VMA from going away. We do, unless we go and audit every single fault handler. But the guarantee we currently provide to the device driver today is that we're not going to delete the VMA in the middle. I think we do need a VMA ref count after all. Thank you, Jason.
So we take the VMA ref count and we do our work.
Yeah.
Yeah.
And so an unmap does have to delay on anything on a VMA with a positive ref count.
The other thought that I had when I was listening to you guys is, I wonder if you could arrange something where there could be multiple VMAs in existence that span the same virtual address space.
No, how would you would need like a versioning system to figure out, well, if someone looks up the address, what are you giving them?
Before you get too excited here, it solves a lot of your RCU problems, because that's how RCU is meant to work, right? Where you can have two copies of things and you have to ask yourself, what what information is in that VMA. I was just looking at it, and it looks to me like the main sticking point is the private data. So if you could work out a lifetime model of the private data where the splitting and the joining, you could have like background copies of the private data that's still valid and background copies of the VMA, and somehow your locking all works out or your ref counting all works out.
You're
Well,
like
at least
talking of almost another abstraction layer where you hand off something so that they can play with the private data, and the private data exists beyond the grace period. Is that?
the private data is kind of logically associated with the address range, not necessarily
Sure, but
VMAs, right?
if the VMA is guaranteed to never shrink or split, then you're only going to get more space. So those addresses with the private data remain constant even though the VMA has been replaced by an even bigger VMA or what have you.
Well, I was thinking in the case that we're talking about the RMAP and how do you work with the maple tree and things, because if you could have multiple VMAs that are the same, like aliases of the same, then somehow you could make all that locking dance work out, because you could update the maple tree RCU world with, you know, one copy of it, the true copy, and leave the RMAP with the old copies while you go then back to the RMAP and fix it, right? It's
Okay, guys, time to shuffle off stage left. You've used your 45 minutes. It's time to get the next BOF on.
Thank you.
Thank you very much.
there, guys.
Assuming Mike is here.
Yep.
Okay, you already have presenter. So if you have any slides, you can upload them. Otherwise, away you go.
How do I upload slides?
Little plus sign bottom left, click on it, manage presentations, click upload slides, and it will
Now,
upload and
yeah. And I don't see anything happens.
Let me.
It did. Okay, I think it worked.
And you want to turn on video as well?
One thing at a time. Okay, so a short recap. What are we talking about? The direct map. I apologize for ARM and PowerPC folks. They call it linear map. The direct map is the mapping of the physical memory with some probably some offset when a randomization is enabled. But for the simplicity, we can assume that there is no offset. So this example shows how two 8 gigabyte physical memory banks are mapped into the kernel virtual address space on x86. So the bank that starts at 0 will have a virtual address of 4 Fs, 8, and then zeros on 4-level system. And there will be a hole between the banks, and the second bank that has physical address of 28 zeros will have a virtual address of FF8 0280. So the direct map is one of the main vehicles to access physical memory via kmalloc page, struct page, and so on. So practically anything that doesn't use vmalloc accesses physical memory through direct map addresses. Now, there are cases for x86 and PowerPC. A direct map is created using large pages as possible. So if there is enough memory, x86 uses 1 gig pages to create the direct mapping of the physical memory, and the areas that can't be mapped with gigabyte pages are mapped with 2 mega or 4K pages. There are cases when do you still hear me?
Yeah, I hear you fine. I think Vlastimil was trying to ask a
It
question.
warned me about loss of a connection. Sorry.
I can hear you too.
So there are cases when certain operations require splitting of the large pages in the physical memory, in the direct map, and this causes some performance degradation depending on the area, on the benchmark, and what is happening. So in a sense, if we'd like to have I think it's the next slide. If we're allocating an object at this address and then we call something like set direct map invalid or set memory read only or set change any other page attributes, we would cause the split of 1 gigabyte page that maps this region, and it will be mapped as 2 mega pages at the beginning, 2 mega pages in the end, and then these 2 megabytes will be mapped with 4K pages to allow a change of attributes in a single 4K page. The use cases, there are a couple of use cases that already exist in the kernel that cause these splits of the direct memory. These are modules, BPF, ftrace, kprops, essentially anything that calls set memory APIs. There is also memfd secret that splits large pages in the direct map. And the upcoming use cases, such as protecting page tables with PKS, and AMD secure nested pages that requires to exclude pages from direct map when they become guest private and put them back when they become shared between the host and the guest. I think TDX will also need something like that. I'm not sure. And regarding the performance, last year I ran some benchmarks on my laptop. So these benchmark checked what happens if the direct map is entirely filled with 4K or 2 meg pages. The results I'll show in the next slide are not so disastrous. And I remember the Intel 0-day lab also did a bunch of experiments and published their results here. So it's not really awful, but it's still not nice to have 4K mappings. There was no clear winner for 1 gig or 2 meg pages, but it's definitely a 4K underperforming all the cases, I think. And another thing about benchmark, these represent data access. When I tried to check what happens with the fragmentation of high kernel mappings that map the kernel code, the results are far more severe, and I easily got like 20% degradation for my MTU benchmark when the code was mapped with 4K pages rather than 2 meg and 1 gig pages. So the suggestions to reduce the heat of the direct map fragmentation and to allow more API, more functionality that requires 4K pages in some places were largely to reuse the large pages that were already split, and then amortize the effect of direct map splitting and provide 4K pages from the large pages that already were allocated. Like when there is a request for key that will have different attributes in the page table than its neighbors, we allocate, for example, 2 megabyte page and split this page to 4K chunks and hand out 4K chunks each time a new 4K page with particular attributes is requested. And there were a couple of variants of these mechanisms posted on list. There was some sort of caching with which I implemented with genalloc for secret mem at some point of its the patch's lifestyle. There was what Rick implemented with the shrinker, and he called it grouped page cache, grouped page allocator for the page table pages. And there was my last RFC about making a cache with a shrinker, kind of next level to the page allocator. Basically, we've stopped the discussion at that point, more or less, without actual agreement where the cache should be placed, near the consumer or near the page allocator. And this is both mainly to discuss the alternatives. So I try to summarize at least my view on how this works. The caches that are closer to user are probably simpler to implement. They have better access control in the sense that the user knows how the pages are used, what attributes they have. There is a possibility to compact those caches to have ability to recreate large pages when the cache becomes fragmented. I believe these caches would have larger memory overhead on overall system, because if there are several users that use such caches, each cache will have its own stale memory that can be reclaimed at any time. There apparently will be higher fragmentation of the direct map. There will be more splits than with a unified cache or something like that. And whenever the user frees a page, it should be freed exactly to the cache it was allocated from. And from my experiments I've done for the last year with different address space isolation stuff, freeing is the most difficult part. Because when you allocate the page, you know what context you are in, and so it's easier to put it in the right place, right page table, whatever. When the page is freed, especially if we have to reuse existing freeing mechanisms such as TLB, MMU gather, and so on, or page freeing via in the VM scan, the pages, the only information we get about the context is what we may store in struct page, and it's not very convenient. So in that sense, if we move the key pages as close to page allocator as possible, it probably will result in more intrusive changes, and the cache will be a black box to its users. So it would be really hard to make allocations movable and do something like compaction, for example. But I believe it would be more memory efficient overall, with lower fragmentation of the direct map. And it's not my bullet, core MM integration. Vlastimil?
I thought it was your bullet.
Oh, maybe because so given the integration with the page allocator, or closeness to the page allocator, probably the freeing would be not as complex to implement, and I think it was the idea. Oops. So that's the intro, and now I've seen there was a question in. I've seen there was something in chat, but it was not about this.
I was going to add, Mike, the other benefit of the page allocator is that you can use the buddy parts to get higher order allocations, which would actually be useful for the
Right.
the PKS table stuff.
Right. Otherwise, you'd need to re-implement it in the cache that is per
Yep.
user, close to user. Yeah.
Why do you need higher order allocations for page
Page
tables?
tables, for instance, on x86 require 2 pages for PGD.
Yeah, for I think also for PTI, there's a order 1 allocation.
The PGD, when PTI is on, the PGD
Yeah.
allocation is order 1.
Yeah.
PT should be order 0, no?
When
Just
PTI is on, there are
for-
2 checks in PGD. One is user visible, and one is only kernel visible. And
Yeah,
whenever there
That's
is a
PGD, yeah, but PT,
PT is order 0.
But it's the one that gets, it's not the one that's, the hardware doesn't use an order 1 page, but just the kernel does or allocates an order 1 page. So it's just how the software is written.
In general, PTI can be changed to use per CPU offsets or something when it does the context switch.
Yeah.
But the bit flipping is neat trick. So my next thought was to try to actually make it a migration type in a sense, migrate type in a sense. You get the nozzle and list to freely area and see what we can get from it. I never actually started to implement it because I really don't have enough background on how page allocator works and so on. It will take me a while to get there. But the idea was to do like something similar to migrate CMA.
yeah, I noticed in your RFC that you mentioned it as a possibility, and I was thinking a bit about it today, and yeah, I was going to say that maybe that should work, but you already planned it as well. Because one of the issues you had in the RFC was that you used some more bits from the page block map. I forgot the exact name, but now we use only 4 bits. and
Yeah, I
we
remember
needed-
I should have used 8, but I
Yeah,
used 5. Yes.
which doesn't work, but for migrate types, I think there's like 6 of them at most today. If you have CMA,
I'm
and
afraid
everything.
we still need to increase the page block bits.
I think if you add one more migrate type, it will still fit in the 3 bits we have for that. And
We have
hope
movable, reclaimable PCP, which is 4. CMA is 5, and isolate is 6.
I think PCP types is LES.
Yes, it's LS with high atomic. So 1, 2, 3. We have 4.
I think we have 6.
We have 4 unconditional and the 2 more conditional.
Yeah, so that would be 7.
That would be 7.
Should still fit within the 3 bits.
Yes.
And if it would be a migrate type, then hopefully would also don't need special cases in the body operations.
It will need some special cases like CMA, I believe, because you can't fall back from it to different. You can't fall back to it.
Fallbacks have some tables that can be set up properly. But the question is if it has to detect like merging 2 blocks where one of them is of this type, and I think it shouldn't.
I think we shouldn't merge blocks with this type. So they apparently they would be excluded from compaction and so on. My
then
feeling is we'll have some special cases like CMA does in this, but probably in other places. We'll.
And I'm not sure if we need any special page flag or just by seeing it's in the proper migrate type.
I don't think I'll need a page flag. I think we take 2 meg. Let's consider x86 standard sizes. We take 2 megs and we mark the entire page block as migrate type, whatever it's called, and so the allocation will be quite similar to what I did in the previous RFC. And the freeing will see that migrate type is such and such, and it can put the page back on the same, on the appropriately list without having a page, flag. Page flag would have been easy. If we had page flags, it would have been easy. Then you can check if the page needs some special handling virtually anywhere, right?
By the way, does any of the use case need to support a situation where we don't know upfront that this page might be eventually at some point needed to be set read-only or unmapped?
Yeah,
I think SCV and TDX.
So we should support also like converting arbitrary page to one of the to this scheme, which I think should work, right? Because we would just change the migrate type of the page block, and basically that would be it, because then it would become part of this cache, and all the further freeze
what
of
you suggest?
page would.
Like I've seen in the CV patches, they do sometimes a set direct map on, set direct map off, set direct map invalid, valid, whatever. So you suggest that whenever page gets different attributes that its neighbors, we mark the entire page block as let's say not in direct map or somehow. And then whenever pages are freed in this page block, we will know to reuse them as a part of this new migrate type.
Yes.
Yeah, it makes sense.
But the question is, can we detect the cases where we no longer need this and convert the page block back? Probably mean like scanning the direct map, and if we see that all the PTs are mapped and read-write, then we can convert it to huge page again and change the migrate type.
It's more like scanning.
Because we have no other tracking except the page tables.
We can scan from the free list side. So whenever we have 2 megs free in the same.
Well, if it's free, that's the simple case. But
you mean what happens if we have the same 2 megs with the same permissions again, or at
Yeah.
some point.
Because
Uh,
if we just temporarily change some page to read only and later back, while there are other
it
pages
will be
in
like
the same
PHP,
2 megabyte block, yeah. Whether
will
it
be
would be worth
quite.
to support this detection that we can
I think
convert the
Kirill
image.
has some patches about something like that 2 years ago or so, doing a collapse of mapping in the direct map,
Okay.
but he didn't hook it into anything particular, and then I believe he stopped working on this.
I mean, I think the easiest place to check would be when you're setting a page read write. Just check if the rest of the larger page is read write and do it then. It's already a
Right.
pretty heavyweight operation.
So I mean, like, check the other 511 pages.
Or just schedule this check and then
Yeah,
periodically
that would be good.
process the scheduled.
I mean, you also probably want to go batch the the reconversion to large pages as well. It'd be nice if you could do one shoot down for several 2 megabyte regions of broken down to 4K pages.
I think we can save some shutdowns on some of the transitions.
Hmm.
It depends on the usage though. So one of the thoughts why I suggested using 4K in the cache and then letting the actual user to decide on the final permissions was partly because of it, that when you allocate the 2 meg page and split it into 4K, at the page allocator at the cache level, you don't need to bother what actual permissions will be. You only need to provide 4K pages for the users. And then the whole TLB management will be delayed until the actual user would like to change the permissions to read only, read write back on, and so on.
It would be nice if when you got those 4K pages, they were unmapped already, because then you don't need to do a shoot down to set the permission. They're just ready to have a permission applied to them.
So I actually thought that I keep the 4K pages mapped and they are still mapped in the cache. And then the user will decide when to do the shoot downs. And Mark says you want to place pages. You might want to place that in the pages before mapping. I think, Rick, actually you had some use case when you needed to invert the mapping and mapping in the page tables because you had to have it mapped.
Sorry?
I think there was a case in the PKS page tables when you needed to somehow do additional unmap or additional map to make to update the page tables. Maybe
Is
I'm
it using KMap local, therefore not the direct map, but something temporary elsewhere, or not?
Well, for PKS, if you need to write to these pages, you just can toggle the key. It's pretty easy.
Oh yeah, that's
so
based on the keys.
I'm not quite sure what.
You just write MSR.
Yeah.
Yeah, you don't need to update the PT.
But I mean, if you're allocating a bunch of if you have some usage that wants some kind of permission page, and you're allocating a bunch of you need to get a bunch of pages like page tables or something, and then you have to shoot down every time. I'm not sure that I mean, you're right that you're clustering. You're still getting the clustering on the direct map, but you're not getting the shared shoot down. Like the fact that you could batch, you talked about amortizing the cost of the shoot down. So you convert a bunch of pages in bulk, and then you get a bunch of pages from that one shoot down. If you just leave them as read write.
But then for your use case, for instance, for PKS, if we have it unmapped from the first, from the beginning, like whenever we allocate to make page, we unmap it, we flush the TLB, and then when there is a request for 4K page, it should be mapped back again with the new permissions, right?
So you're saying that page allocator would do
So
that before application of the permission, or the caller of the page allocator would?
The caller might need to map it. So for instance, if it will be page table page, you'd need to map it to create the page table entries, and then you set a new permission with the, say, PKS, right? So this map back and forth probably is you still need, well, actually with PKS, you don't need to flush TLB, right?
When you apply a PKS key to some memory, that does require a flush. But the thing is, it won't require a flush if the page was already unmapped, because then it can't be cached. So that's kind of the benefit of having in the page allocator a bunch of unmapped pages. And I almost wondered if like we could do something like we combine these two things, where the page allocator manages unmapped pages, and then maybe you could even get handed back permission pages, and it knows it can re-unmap them and back in, because you can, if you unmap a page, you've kind of done you can do one flush for a bunch of pages that are going to end up being in different permissions that you don't even know yet if you have them unmapped, and then when they get handed back, you just quick write the permission to the page table entry, and then it's ready to go. Does that make sense? And so you could even have the per user caches could handle applying the permissions if you don't want to have the page allocator know about every type of different permission that might come up.
Maybe. I need to think more about it.
Okay.
But maybe. Now, Vlastimil, did you look into SCV actually what they need? Because I only had some quick glance of the patches and.
Yes. So for one of the cases for the SCV SNP is that some pages allocated that should be private in the guest, which means there's this encryption going on, and the host is not supposed to access it. And for that, there's a RMAP table that tracks the state of each page, and so this page will be marked as like the guest private something, and then the problem is that if this page stays mapped as part of some 2 MB direct mapping, and the host accesses some different page within the same 2 MB, then the SNP machinery will check the RMP table for all 512 pages, because it is about to create a 2 MB TLB entry, so it has to check everything within these 2 MB, and it will see, oh, but there's one 4 KB page within this range that gets private, and we are not supposed to touch it, so we cannot install the TLB entry for it, and therefore it all fails. So it needs to split the map even without needing to change permissions.
So it simply need to be 4K page,
or I think what they do is they unmap it.
It should be unmapped
because it's simpler, and then we can detect that there's such page.
So 2 megs should be splitted, and then the page that became guest private should be unmapped entirely.
Yeah.
Rick, do you know if TDX does something similar, or James, maybe you do?
It has something else. I can't give like an authoritative answer, but I believe it was around writes to the encrypted memory. So yeah, I can't give an authoritative answer. Last time I saw that series was focusing mostly on the user space mapping and not the direct mapping, but I'd have to go back and look.
I guess Dave Henson would know, but I don't see him.
I don't see Dave here. James might know. James is too busy with something different, probably.
You'll have to repeat the question. Hang on. What?
Does TDX need to unmap private pages from the direct map? If you know.
TDX needs to unmap the guest VM pages from the direct. Actually, I don't think it needs to unmap them from the direct map. It just needs to make them inaccessible to anybody else to prevent the machine being crashed. So unmapping them from the direct map would be the safest thing to do. Kirill's the guy who's been doing the patch set for this.
But Kirill is not here, right? And Dave also is not here. Because last email was saying that SAVSMP needs to, if there is a 4K out of 2 meg become private to the VM, they must be unmapped from the direct map. Because the way how SMP machinery works. So
I think that's a good idea.
TDX would need something similar.
Probably. I mean, it would certainly prevent ROP attacks from crashing the system using the TDX page protection.
So essentially, if this page is mapped in 2 meg in a TDX system, any access to those 2 meg may create a machine check, may cause a machine check.
Yeah. So I think I'm remembering that when we were working on this, we thought that it could be, if we're going to go through the trouble of having this the special management of private pages, that it could be nice to have a mode that just uses software to, existing hardware features to unmap the guest memory on the direct map, kind of like the exclusive page frame ownership concept. And I think that's where the direct map unmapping came from, because I think at some point that series did have a direct map unmapping piece. But I'm just looking through the last RFC and I don't see anything about the direct map.
That's about the TDX or
yeah.
series?
So I think it's just focusing on unmapping from host user space. So like QEMU's view of the
Is it this set that used the memory failure infrastructure for that? Or it's another one? I'm quite behind the list. So.
Oh yeah, Greg says that memory failure is also a use case because it wants to avoid speculation accessing the poisoned memory.
Yes.
So another thing on the having a cache of unmapped pages is that all the vmalloc. So there's also applying kernel memory permissions to the vmalloc alias, which there's not always a vmalloc alias, but you can create one. And when that happens, you don't really care about the direct map anymore. So like for modules, for example, it's going to go get random pages from the page allocator and then set memory at the same time, the permissions on the direct map and on the vmalloc alias, like for example, like setting it executable or something. In which case, if you have unmapped pages in the direct map, you can just leave that alone and just apply the permissions on the vmalloc alias. So in this case, you don't need to do if you have unmapped pages already, you don't need to do any shoot downs. You can just apply the permissions and, as long as you have some other way to load it.
The initial shutdown. When you
I mean, at some point you need to batch unmap them, but then after that, you can just sort of apply, you can have like a, for example, if you're going to load, sometimes people load lots of JITs BPF JITs or something. You can do that with zero, average zero shoot downs. Of course, there's the batch shoot down at some point, but
And
it's
then
kind of a nice benefit.
BPF only uses the vmalloc alias.
Yeah, I mean it's actually in a different address area, but it's basically a vmalloc mapping.
Okay.
And I think also, for some of the PKS usages, like there was the one where they were, it was Elena Reshetova was doing one where you would map in vmalloc using PKS to protect a key. So all those kind of key storage usages also could benefit from like having a shoot downless creation of PKS memory.
I remember there were some patches Ira and Elena did about using a PKS to protect the key rings and so on.
Yeah, and I think there could be there could be more kernel secrets that could use the same thing, but depending on how often the secrets are allocated, you might not want to do shoot downs all the time.
Right. So Vlastimil.
Yeah, I have just some implementation concerns. If we go with the migrate type way, then it would be very hard or intrusive if we wanted to guarantee that all pages that are on the free list of that migrate type are in some predefined state, like unmapped, like you just proposed. It would be fine if we could just assume that mostly they are in that state, and if it happens some of them is not, we will just do the unmap on allocation and pay this cost. But otherwise, if we just check, okay, is this page really unmapped? Okay, it is. I don't have to unmap it again and do the TLB shutdown. Then it should work rather fine and not be too intrusive on the page allocator. If we want this guarantee, then we would have to be as intrusive as the page isolation, I'm afraid.
I think it's more trade-off of how fragmented, how less fragmentation we want to allow versus how easy it is to manage the whole thing. Because
I didn't mean fragmentation, but batching of the
fragmentation of the direct memory. I mean that. Okay, let's say we have a lots of memory at the beginning, and it's until the memory usage builds, so we can easily allocate high order to max pages and just split them and keep them in this list, and this won't be a problem. But at some point, we won't be able to allocate to max, and then we'll have to split. Other places where there will be 4K pages of different that belong to different domain protection domains, let's say. So if we do not attempt to reduce fragmentation very much, if we kind of let us live with that more pages get fragmented as the system lives, it doesn't seem to be too complex to do all the whole tracking of unmapped versus mapped. Like, okay, we can't allocate to max, so we allocate in 4K or maybe some incremental high order, but we split it out from the direct map once, and then we continue to use it as unmapped.
Yeah, but there will be other pages in the page block which we couldn't get because we don't have 2 MB page blocks available anymore, and we cannot unmap those. And at some point, those will be freed and merged with our pages, and then we would have no guarantee that what's on the body allocator of this migrate type is really unmapped or mapped.
we can check the page table
Yeah.
when we free a page from that page block.
Yeah, that would have to be done.
And it's not that complex, and it's not that slow.
Yeah.
We have
So
to make
there
sure
is-
that we handle if we're going to also ever add in the repair.
Can you repeat, Rick?
Yeah, so you're saying if we want to check if a page is unmapped, we can just check the page table. Was that your comment? Yeah, I just said that if we're going to ever remerge the pages, we have to make sure that those checks don't race with the remerging.
I thought we would check in one of the free sum pages.
Yeah. We talked about having like a batch list that would accrue things that's supposed to remerge.
I think these pages should not go to PCP lists anyway, right?
No, we wouldn't probably make this a PCP list migrate type.
It's 1 minute, and then when we call one of the free one page or free the page or one of those that somewhere deep in chain, I think we can make the check race free.
But yeah, it does seem like it's not too many more accesses than just checking a page flag. So kind of like the idea.
So I think we have some ideas how to move forward. After the conference season is over, I will try to create the new RFC. And now time is up. So thanks, everybody.
As a reminder, you can pick a hack room and move to it if you want. We've got quite a few empty ones.
I think we're good, guys.
I think there's... Yeah.
Okay, in that case, I need Atish Patra for risk 5. Is there anything you need to present?
Yeah, I have like just a couple of slides just to start the
Okay, so I made you moderator, presenter. If you look at the plus button bottom left, you can click on it, manage presentations, and then upload slides, and it will switch them from mics.
Okay, I'm doing that.
Hey, I'm on here too, Atish, but it doesn't like my video. I don't know how to set the device.
Thanks, Mark. Yeah, I think that's okay. So I think it's 9:15, so we can start.
Atish, I'm here as well. This is Kumar.
Hi, Kumar. Kumar is here. Al is here. Okay, awesome. Wow, you have a top angle view in Philip. Hi, Mark. Hi, everybody. This is welcome to the Risk5 BOF. So we are just continuing discussion where we left the Risk5 MC. You might not have met, some of you might not have met Mark. Mark is the CTO of Risk5 International Organization, and he oversees all the day-to-day things for all the specifications, all the development going on within the Risk5 International Organization. We wanted his input on some of the things, so we requested him to attend. Thanks, Mark, for joining in. So without further delay, I'd like to just briefly state where we left and then start the discussion. So this is where we left during the MC. We just to give you an overview. This is more about this session. We'll discuss more about the platform specification, and if time permits, probably we'll discuss what to do with the D1. So this is where the platform specification is already there. It's stable from our side. So if you have any comments, it's still going through the review process through the distros and other community members. Go take a look. If you have any comments, let us know. Broadly speaking, it has two platforms. One is OSA platform, which is targeted towards the rich OS, such as Linux, FreeBSD, Windows. And there is a base and a server extension. So base is targeted towards the minimal platform that can boot Linux, something like Hi5 Unleashed or Unmatched, or let's say Allwinner D1 or Beagle 5. And server extension is obviously for enterprise. And then M platform is everything that doesn't boot, doesn't have AS mode or doesn't boot on rich OS, something like RTOS or bare metal. And it has a PMP extension apart from the base. So for the M platform, since that it's a wild west area, we can't really specify a lot of things. So base is really minimum things. And for security aspect, there's a PMP extension if the vendors want to implement some kind of security, and if they have a lower privilege mode such as SRU. And the schedule is, current target is to make it freeze by RISC-V Summit, which is in December. And we are working towards that. Okay, so as we discussed during the RISC-V Plumbers, here are the specification status in that are relevant to platform or relevant to Linux. HV, the PBMT extension that modifies the page table attributes for the non-coherent cache, non-coherent IO devices, and then CMO, and then the counter overflow extension SCOP PMF. All of them are frozen. So they are under public review in the public domain. We can go and take a look at the specification in the ISA Day mailing list. I also sent a mail to the Linux RISC-V. So all of these extensions are frozen. So if any of those extensions that has patches pending in the mailing list can be merged, or can be at least reviewed and get merged eventually now.
So is this like the entire set of extensions that got frozen?
No. There are more than those. So there's S-Time and others, but those are the ones that are of immediate concern to Artish.
So I should also mention that there are others here that the platform spec currently depends on that are
I'm coming to that
not
part.
going to be frozen. Okay.
These are only the ISA specification extension. So there are a bunch of specifications that got frozen. I specified these. Go ahead, Mark.
Yeah, I just want to say there is on the website, there's a tech wiki right off the top. And if you go there, there's a URL table, and there's something that says dashboards for ratification. So you can go look there and see all the specifications that are in play. If there was chat here, I can't find chat.
Yeah,
I would go ahead and put the link in.
You can put it in the share notes.
Yeah, I'm having a hard time finding the share notes, but if I find
on
them
the left and up.
On the left and up. Yeah, not on my screen. So I'll try to find them. But the other thing, so the other thing I wanted to say is we've only promised to RISC-V that the platform spec will be a draft mode at Summit, and part of the reason is, and I don't know how much, Kumar, you've shared the dependency spreadsheet, but there's a whole bunch of other specs it's dependent upon. And I didn't want to go ahead and promise anything more than a final draft kind of thing at that point, because I didn't know when those other specs were coming in. I don't have commitment dates on those. So we're trying to be conservative with that. But rest assured, I mean, the goal is to get this frozen and ratified, sometime in the first quarter of next year.
Thanks, Mark. So the reason I specified these because the patches are pending on these. So there are other extensions that went into public review and frozen. I sent an email with the detailed list to the Linux RISC-V, so you can take a look. Coming back to the dependency on the platform. So these are the dependencies that we have on the platform specification that are non-ISA. So mainly profile. So as Mark said, depending on when profile gets stable and frozen, platform spec can be frozen after that. Other specification that are already that the platform specification depends and already are frozen is our EBBR, UEFI. We don't need any modifications to those. Then there is ACPI specification. I think over the period, ACPI specification will evolve as there is more feedback from the distros and from the ACPI community. Yeah, Philip. You're saying something? Okay. And then in terms of the interrupt control specification, the ACLINT and PLIC are frozen, and AIA should be frozen soon. I don't know the timeline. Anup or Philip, any comment on when the AIA will be frozen?
Actually, there's one comment. So we are working on the process still. So ACLINT, PLIC, they aren't really frozen. They're just very cold at this point. So we've referred to them as stable, given that we're still fine-tuning the process. SPI 0.3 is out in that sense because it was going through a different process. So they are similar to being frozen, so we don't expect any changes, but they haven't undergone public review yet. And they haven't really reached the point where we can send them on to this pool for public review just due to a process issue that is being resolved at the moment.
Okay. Okay. So that's all I had for the specification related things. Palmer, any questions?
Atish, so SBI, the recent release, there was no process till now for the pure software conventions and specifications. So going forward, there will be a different process, but till now, I think we'll have to consider this as the release, right, Philip, or anything else with the existing release?
It's actually very simple. So we're moving SPI into the process, and 0.3 is what it is. It's out. There is a software release that goes with it. So that exists, and it exists outside of the RISC-V naming or label continuum. So SPI is V0.3. That one exists, and it goes with
but
software.
is it frozen?
Yeah.
There was never frozen on the SPI specs, Palmer.
No, it was.
I think the question.
Yeah, 0.2 is frozen. Is
So
0.3
the question is here: is it likely to change? No. Any changes
No,
that
is it
goes
frozen? Are you
Yes.
guys providing a guarantee that you're not going to change this in a backwards compatible
Yes.
fashion?
Let Mark speak for a second.
Please. This is the first time we're going through this with the platform spec. There are a lot of constituents, including Palmer and Paul and Krista and Andrew, and we're going through some one-on-one reviews in October. So the intent is that when we say frozen, we mean there still could be change, but it's a very small set of changes. But because this is the first time we've gone through this review for non-ISA specifications, we're taking some extra time to go one-on-one reviews with various people who are constituents in the community to make sure we got everything right. So while you may hear the words frozen or whatever for this next generation of stuff, not the last generation, I'm talking about the stuff that's coming out with this platform spec, just understand that this is our first time and we're still figuring out how to do these reviews and get all the constituents to the table. I've heard comments that there's some issues, and I just encourage everybody, if you have issues, get onto the mailing list for the platform team and come out into the open. We can't have this stuff in incognito and do anything about it. And so rumor and innuendo don't help at all. We're trying to bring things into the light and just get them done. So please be patient with us during this period of time, and understand that, again, it's our first time through with this big a platform spec and all its dependents, and we hope to get everything right, but we're human, we won't.
So, Mark,
We're just talking about the platform spec in that instance, but I thought the discussion we were just having was about SBI, not about the platform
so
spec.
for the SBI spec, will not have any major technical changes. Any technical, if any, there is any feedback that comes as a technical change, it will be in the next version. For
Frozen.
Say again, Philip.
said, which is similar to the definition of frozen, because frozen just says there are no major or no content changes, and if that happens, a new version needs to come out.
Okay, well, that is not my understanding of what frozen originally meant. So,
Okay,
anyway,
Palmer, one thing is that SBI is like one of those specs which will evolve over time. So you will see like for a couple of years more, there will be yearly release or a bi-yearly release because it will evolve, right? So for this year, it is 0.3 and that is frozen. So there is no change in 0.3 now.
So my understanding of frozen did not mean that the spec was never going to change again. It meant that changes would be made in a fashion for which software could be compatible, which is a very different statement. So, you know, if SBI 0.4 comes out and there are no mechanisms in 0.4 for maintaining compatibility with 0.3, that's going to be a problem.
Yeah, so it will not break.
Yeah.
Sorry.
So no, at least we can assure that will never happen, because that's been always goal from our 0.2, right? We'll never break backward compatibility with any of the previous version, starting
Except
with
that that's how we got into this
Hey folks,
discussion.
the state definitions are now in the shared notes. These are the official state definitions. Every single spec has to have this at the top. It is the Bible as to how this works.
Yeah, Palmer, you're saying something?
Yeah, because I'm just trying to point out that the whole reason we're in this situation about ASBI 0.3 is that between RC1, which you guys said was frozen, and the final release, there were, you know, substantive changes. There was one substantive change, which I made because I didn't think it was frozen, to the spec, right? So like, is RC1 the frozen version, like you said it was on the mailing list, or is the final release the frozen version, or are neither of them frozen? Like, which one of these is going to be what I have to be compatible with for the rest of my life?
After RC1, we did this final release, and that is the final thing.
So
which includes your change.
Go ahead.
So clearly, so you're saying that RC1 was not frozen, and that I do not have to be compatible with RC1.
So I think that was a small change, and then after that, some typo fixes also happened, right? So
No, but
happened, right?
changing something from recommended to must is only a one-word change, but it's a big change. Does that make sense? Like, it's a small change in terms of letters, but it's a big change in terms of meaning.
Changing from must to may not is not an editorial change.
Yeah, but so 0.3, so we had an informal process, like a software process for SBI, right? So that's what we had done with 0.2 as well. We tagged a release candidate, and then we did, just like any software, we did a release. That's what we did with 0.3, and we didn't had this nomenclature of stable, frozen, and all those things, because we didn't had any process for the software or conventions, right? So, and that is the two. And if we start labeling stable, frozen, all those things with these tags, it's not fair, because we didn't have a clear process defined at that point in time.
Well, I mean, maybe I'm remembering this differently, but I remember pretty clearly standing up at that whatever meeting and saying that it was frozen, and everybody agreeing to that, and then merging the code. And
that's what we did for the platform. We did that in the platform specification. In the
I was saying for,
meeting.
Sorry, I was saying for 0.2 of the SBI, right?
Yeah,
and at that point, that was as much of a process as there was for freezing something. So we were freezing as much as anyone else did. Right? I get that there's more. Sorry.
No, I'm saying we followed the same process for 0.3 as well, because we just said followed the precedent. We asked
which I'm totally cool with. My confusion here is that when I asked, you said that RC1 was frozen, right? And then there was a change to the spec, not like a little wording change or whatever, a change that actually changes the meaning of the spec and how we probe stuff and whatnot, right? So like, I just need a clear.
Okay, so okay, let's not term that as frozen, because at that point in time we didn't have clear states. Okay, it was a release candidate, and we did the change, and then we released the actual spec.
Okay, maybe.
So,
I'm sorry.
maybe it was just a poor choice of words at release candidate. It was just a poor choice of word used during the release candidate, but 0.3 is the final one.
Yep.
Okay, and specifically 0.3 RC1 is not frozen.
No.
Okay.
And after that we tagged 0.3. It was waiting for any final reviews, just like you reviewed and did some change, right? So.
But you told me on the mailing list that RC1 was frozen, that you froze it because you came on before you had released 0.3 final and told me that it had been frozen for a long time. Like, that's my confusion here, because you know,
I think there's a lot of misuse of this term frozen.
Yeah.
Yes,
Guys,
exactly.
So from now on, let me make it very clear. Unless you hear from Philip that it's frozen, it's not frozen. He is the chairman of the chair of the software committee, and he is the one who actually puts it up to go out for public review. So if there was any confusion in the past, there should never be any confusion in the future. It's got to come from the software committee. It can't come from a committee underneath the software committee.
okay, great. Philip, can you send an email to the kernel mailing list saying exactly what was frozen for SBI, and then we can go merge it?
Happily, again, so that was coming from before, and that's why I said this is still outside of the process, and I'll happily bless it as frozen at this point, because we're not going to change it anymore, and anything else is going to be a new version.
Okay, great. Can you just like write that in an email so there's no confusion about what it means in the whole song and dance, right?
But let me just add one thing in. In the end, Krista is the gatekeeper. Until Krista sees something, there's always some chance, and that's why we say frozen, which means that it's we don't expect anything, but it doesn't mean that nothing will happen. And again, Krista, even with his very trusted lieutenants like Andrew, after they say something, sometimes he reviews it and finds things that need to be addressed. And so Krista,
I know Kirst.
so Mark, that's why these guys are doing one-on-one reviews with Krista of the platform and all the subsidiary specs in October, because if they don't do that, there's a chance that this stuff will morph more than we would like, and we don't want that. So we're taking the bull by the horns. We're having a one-on-one with Andrew. We're having a one-on-one with Krista. If anybody else on the phone feels like they need to do the same thing, please contact Kumar, who drives the platform horizontal subcommittee.
So I think one of the most important things that really needs to happen here is that these processes for how this all works needs to be documented publicly. And the exact meanings of what it means to be frozen, that should be a very special word that no one should use unless it's actually been frozen by RVI. And if it needs Kirsta's sign off for it to be frozen, which I'm still unclear about, or some other committee's sign off for it to be frozen, then this really needs to be clearly documented.
So guess what? It is clearly documented. And
please put it in the notes. Like, where can we find this?
I'm putting the policy in the notes right this second. Just hold on. But let me explain. All the chairs of all the committees have to sign off for the plan milestone, the frozen milestone, and the vote ready milestone. So it's not just Krista. It's Greg for UMPRIV. It's Andrew Dello for security. It's Wei Wu for the ISA infrastructure. And it's John Liddell for the technology sectors. Those are the committee chairs that we have at the moment. And they need to sign off, and I need to sign off before anything goes to a new milestone state.
Okay, so has this happened with 0.3 for SBI?
Like I said, Paul, there was no process till now, and not just SBI, we also have PS ABI specs, which are also under the same purview, because these are software conventions. And going forward, there will be a new process for such specific, which are pure software conventions, okay, or conventions, so to say. It will be different from, yeah, so that's what Philip is doing, right? So Philip can elaborate that. So
yeah, I just want to say one more thing. There is a non-ISA definition of done spec as well, which requires you know, certain things to be done at these points, and you know, people like Gaj and Greg helped put that together. So I'm putting those links in the chat as well.
Okay, so just to be clear then, so 0.3 is not yet frozen from RVI's point of view.
Until it passes through the DoD, it can't be frozen.
Again, with SPI 0.3, we've just talked about it on Wednesday. We have special situations instead it's coming out of the old process and out of the OpenSPI project.
So the other thing is, that's why we have the stable milestone. Stable says it's ready to be frozen, but we have to, you know, dot the I's and cross the T's. And so my suggestion, Philip, is call this stable. Let's go through the process as defined, and make sure that everybody understands, you know, what the process is.
Question to Palmer: is stable good enough for you?
No, stable has a long history of being not good enough. So yeah, I consider stable to be a completely meaning-less term based on how it has been defined in the past. If there's a new definition, I'm happy to read it.
And if I call it the new stable?
You call what?
Stable.
Sorry, I think it's like cutting off the first word or two of what you say.
That doesn't matter. I said the new stable, given that the old stable was apparently not stable.
So yeah, like if you have a new definition of stable, and I'm happy to read it. I think Mark might have linked to it. I could try to read it. Probably won't be able to do that in real time right now. Also, I'm like falling asleep again. So anyway, if there's a definition, I will read it, and then we can discuss whether or not that's suitable. But like stable before basically meant like the exact binary of that spec is not changing, but we're not considering it all when doing future specs, which is like, that doesn't help me any.
So look, folks, I'd rather us take a little extra time and get this right, because in the community, there's been a lot of frustration, and, you know, we don't want that. We want this to be done right. I mean, everybody wants this to be done right. We're not, you should not rush this with respect to this. If there's reviews that need to occur, and we know there are reviews that need to occur, let's get those done before we go ahead and call this thing frozen.
Yeah, I agree. That's why we're just trying to make sure that everyone's on the same page about frozen being a very big deal for the software folks. And not.
So
just let's take two steps back, maybe. Let's take 2 steps back, maybe. Mark, you mentioned before that we have ISA and non-ISA. But actually, we're trying to subdivide the non-ISA into non-ISA, as in hardware, like debug, and software only, software conventions.
Right. But
given that that's a different life cycle.
Yeah, but you're not going to get away from the sign-offs.
Yeah,
no.
A lot of these specs that are probably most likely to be defined as software-only specs are actually going to wind up having hardware implications in certain cases.
Yeah.
So we need to be really careful about that.
Hey, look, folks, I just want to tell everybody on the phone, part of the reason why you see these policies sitting here and why you see this discussion occurring is because we care about this, okay? And we're not trying to be cavalier about this stuff. We're trying to go ahead and make it reproducible, make it well-known so everybody knows what the rules of the game are. And we're trying to make sure that, you know, we have consistent buy-in inside of RVI, because, you know, at times we have not. And that's the goal of this. So the definition of done is, for people who don't know, that's the list of things that need to be done for each milestone. And so the definition of done includes sign-off. The sign-off is required no matter what kind of document or specification it is. And you know, for example, security needs to sign off on everything. I'm sorry, they need to see it, right? And so so even if the other timeline and roadway to get to ratification is simpler or easier for some kind of specs, we still need to do some basic stuff.
Yeah, I think it's why it's very important that people don't throw around the word frozen unless it is actually frozen, because it gets very confusing.
Okay.
And I'll apologize in advance. Those documents are not small. So the ratification one is quite long, and you know it's relatively new. Nobody wrote down what it took to ratify until the summer when this thing was created. So so it's a relatively new document. If you find something that's wrong, help us make it better, please.
Yeah, I mean, it's fine. This is like ISAs are a complicated process. It's just that we really need to know what it is that we are like meant to be looking at in order to have any shot at building something around it.
So one thing to remember is we're also having that ongoing tagging here or ongoing pull from different sides. So some people need things to be done faster to avoid fragmentation or to sum off fragmentation, while on the other hand, we can't really force things to be completed and need to take our time and go through the process and run it by everyone. And reviewing everything by security, for example, takes a lot of time. And also software has a lot of things to review these days. So that said, we're really trying to move forward as well and take fast-track approaches, simplify the software specifications to avoid fragmentation occurring, because some people just don't want to wait. And as we've seen with the page table attributes, the page-based memory types, or vector 0.7.
Okay. I think in the interest of time, let's move to the next topic. And just to summarize here, so from a task group that worked on SBA specification, we consider it stable / frozen, whatever you want to call it, because we don't expect any changes. But as soon as there is a process defined for software specific.
Sorry, but hang on. It's not stable or frozen or whatever you want to call it. We just talked about not throwing around the word frozen.
I'm not throwing. That's what I'm saying.
Well, but you did.
No, I just said.
Yeah, you guys should not.
I just said we don't expect any changes, but as soon as the process is defined, we'll go through the process, and from RVI it will be called frozen or after the feedback, whatever happens. And as per my understanding, on the RISC-V website also, any frozen or a ratified document will be uploaded for everybody's so that everybody can take a look into, and SBA will also be included in there in a couple of months. I don't know when that will happen. But let's move to the next topic for ACPI. So there are in the MC there are some feedback that whether the distros want ACPI or not. As per our initial feedback with the distros, they want ACPI, so that's why for the server, not for the base. Yeah.
Sorry to interrupt you. Did you skip to the next slide, or are you on the same slide?
No. I have the same slide. Just I'm talking about the ACPI specification. Okay. So just wanted to clarify that we had an initial call with Red Hat, and then they suggested that we should have ACPI for server platforms. Is that correct, Kumar?
That's correct. Al, I think Al is on the call, right? So Al, your feedback here with everybody on would be really appreciated, right? So we briefly spoke a couple of months back, and the feedback that you had was for servers specifically, the boot process would be UEFI and the discovery process would be ACPI, right? So that's something that we had agreed on, and just wanted your feedback again with everybody in the room.
Yeah, I mean, the basic rule is if you're going to run RHEL, you will provide UEFI, you will provide ACPI. The closer it looks to the SBPR and SBSA requirements, the better.
Okay.
That is still true.
Okay. And then again, just to expand on to that, thanks a lot, Al. That's consistent with what we spoke earlier. And if there is any other distro vendor in the room today in the meeting, please provide your feedback.
Yes, please do not make me suffer through any of this crap anymore. I deal with this on Fedora. I deal with this on OpenSUSE. I deal with this on Magi. I deal with this on OpenMandriva. I don't want to deal with this with the RISC-V bring up. Please, for the love of all things good and sane, make it so I don't have to figure out how the bloody hardware works to start the computer.
Okay, and which distro is this that you're representing?
And also, which direction is crap? Because people have different opinions on that one.
Well done, Palmer.
Yeah, I guess we might have misunderstood that, and the real request was to bring device tree back as the only true solution.
Yeah, just please be specific.
Okay, somebody's getting a stake in the heart for that suggestion.
I still remember open firmware, and it wasn't all faulty.
My basic ask is I generally don't actually care which way it is done, whether it's ACPI or device tree or whatever, but I want in the what I would love as a distro developer is that in the actual standard that it is burned into the board. It is on the EEPROM, and I don't have to care about it, and it cannot be updated, so the onus is on the hardware vendor to make sure it works. Because that is the problem with ARM and MIPS and everybody else.
Now you're going to start a whole nother argument. So sorry.
You know what? I don't care.
I tried
I
that
will
too.
die on this hill. I will die on this hill. Like
I'm not
because
people have been like arguing about this for
sounds
like
like
at least 10 years.
Open firmware.
Yeah, like even on PCs, right? You're always going to have the ability to update those tables, right, with BIOS updates. So
yes,
making
but
it
it's not my
non-changeable is not gonna
responsibility.
happen.
It is not my responsibility. I don't want to be responsible for that. I don't know anything about anything. Please don't make me have to think about it.
No, I think point taken, right? I think the whole idea here is that OS is completely agnostic to whatever the hell is happening in the firmware and the BIOS, right? And that's the whole idea here that we're trying to achieve.
Well, but I think part of Neil's point though is that we insist on standards all over the place, right? And what the hardware vendors do is say that's nice. We're going to do whatever the hell we feel like doing. That's just that it ain't gonna work, right? It makes life miserable for Neil, makes life miserable for Rel. No, don't do that. Yes, you can update your firmware, and please do. That would be really nice for a change. But don't make that mean that I, as the distro developer, have to understand exactly what you have done in your hardware and how it works.
Okay. Well, this issue that we're not going to solve it. It's not specific to RISC-V, right? This happens with all the ISAs. So I don't. This is not something that I think we have the ability to solve.
Well, and traditionally the way this is solved is logo programs, right? It's finding ways to give the hardware vendors incentives to do the right thing.
Right.
I assume we have a slide to argue about that one though too. So.
Yes. Exactly. So leading to that discussion. So that's exactly what I wanted to discuss next. Is how do we make platform specification mandatory, or do you even need to? And how do we deal with logo branding so that vendor actually follows this? So
first of all, Atish, let me stop you there because you got the branding wrong. It's RISC-V compatible with the OSA or for the OSA platform. It starts always with RISC-V compatible.
Yeah, because that's what we trademarked. And then 4 is the adornment. 4, and typically we use a profile or a platform name.
Oh, that part I intentionally left because that's what is fixed, right? So that's a common prefix. What we worried about is the postfix.
No, this is only the cause for very long email threads. So please always use it correctly because otherwise your inbox will fill up quickly.
Okay. So
yeah, so one comment also is that the RISC-V platform specification, at least from the point of view of many of the upstream software projects, will never be mandatory. There will always be boards or devices, whatever, that won't align to that. We see the same thing with ARM because a lot of embedded users won't care about the platform spec. They won't care about PCI or whatever, so they won't put in PCI.
Yeah, that's the magic of RISC-V. Not only do they not have to conform to that, they don't have to conform to the instructions, right? So
Then they don't call themselves RISC-V. That's
Well,
that's simple.
Well, they can't brand if they are, non-conforming and compatible. But there's a lot of room for customization on top of the base, right? So that people do have the flexibility to do stuff and still be compatible. And if you do anything above and beyond, obviously you're on your own. But again, I mean, I agree with what Paul just said. There's always going to be divergence. We're just trying to make it as easy as possible to run the same, in the end, run the same application from implementation to implementation. That's the end goal.
It feels like y'all don't want to say that not just the ISA, but like the way that the hardware is configured shouldn't be. It's like it feels like you don't want to say that in order to call yourself a RISC-V system, you don't want to actually say, you don't want to prescribe that some minimum requirements on the hardware is necessary. You won't, and that is flawed.
I think it's contrary to that, actually. I mean, the whole purpose of the platform spec is to constrain it.
So
it doesn't seem like it.
Mark, maybe let me jump in here and explain it a bit, because actually we are saying that if you want to brand yourself as RISC-V compatible, you have to have minimum requirements, but it depends what you do it for. And maybe we take 2 steps back and not just 1, because all that we're doing with the platforms, with OSA, only matters to people who want to take a ready-made piece of software and run that on a piece of hardware, and that want to go get their hardware and then get their software. So basically somebody buys Red Hat Enterprise Linux and wants to know whether it runs on the server that they're buying. So those are the only use cases where this branding really matters. And on the embedded side, we're more talking about source code compatibility. And there it's also about, I get that chip, or I want to design with that chip, and I have the software, those libraries. Is the porting overhead going to be small? So this branding only works there. And then yes, we have RISC-V compatible with the base specification, with the platforms, with the ISA. Again, that only matters to people who want to know what they're buying. And unfortunately, the use cases are quite different for embedded server, desktop, and for that reason, there's that flexibility.
But I would also argue that you've got the same issue on the embedded system side, right? So there's essentially 2 classes of embedded systems, right? The one you're talking about, where God only knows what they've done, right? And only they know, and nobody else is going to find out. But then there's also the, I need a subset of SUSE, Fedora, whatever it might be, and I want to just run that. So you need standards for that as well, right? And part of the System Ready project that ARM is working on, that's actually part of the environment that they're working for as well. Can't hear you, Philip.
Philip, cannot hear you.
Hey, just a time check here.
I'll mute it, sorry. So the problem is that is exactly OSA. So OSA has a base and has a server extension. And if you're targeting automotive head end, you're probably OSA base.
Okay.
Or some future extension. We have M, which is source code compatibility for embedded control. You're trying to port your motor controller to something else. And that's what we're trying to do. And then there's God knows what if you're building a Bluetooth headset and nobody else is ever going to run software on it. I used up 2 minutes? That's not fair.
I think we need more discussion. Do you want, so everybody has time? Can we move to a hack room after this?
I unfortunately have a big meeting after this, so.
Okay then.
I don't know, maybe we can find something else.
I've got my whole day free. I can sit here and argue with everyone as much as you want.
Yeah, there is a platform HSC meeting coming up soon. So I would say we all reconvene in one of the many RISC-V meetings, because pretty much everybody is going to be a member anyway.
Well, I'm not, but like, whatever.
Yeah, you can join
It costs
the
money.
risk5.org.
Yeah, but it costs money, and I don't have
No, it's free.
It's free for individuals. It's free for individuals.
Oh, okay. Well, then that changes things a little bit.
Good.
Okay, any so
It just costs time to actually participate.
Oh, that's easy.
And it ropes you into a bunch of IP stuff, but that's what, you know.
Oh, that's less easy.
okay, so any conclusion? How do we make vendors care about the specific platform specification?
Well, I thought that you guys were reaching out to all of the major Linux distribution folks. And
Oh, no,
trying
no,
to
I'm
get
not
them to
talking.
review it, right?
Yes, we, as per the last slide, we already have discussion with Canonical, Red Hat and SUSE. It's scheduled next week. No, but I'm worried about, we'll get the feedback from the distros and then the specification will be done. But Palmer's concern was what happens platform vendors, not the distros.
Yeah,
Platform vendors don't just care about the branding.
So my worry was, sorry.
Go ahead.
My worry was more broadly than the platform spec. Like the D1, like repurposes reserved bits of the supervisor spec, which is super scary on my end, because then like if that is still called RISC-V, like what isn't? Hey, Gau's here.
Hello. Yeah, you mentioned the D1.
Yeah.
Yeah, the D1. We designed the D1 in the 2019, 2 years ago, and at that time we don't have any spec to follow, and there are no solution for the non-concurrency DMA. Yeah, and we found a customer, a winner. He used to be a ARM-based SoC manufacturer. Yeah. And all his driver is.
Sorry, we're getting the boot
sorry.
from James here. So.
Yeah, you're going to get booted out here by me soon. You can take this to a hack room. We have plenty of hack rooms free.
Sorry.
It won't be recorded, but you can take that.
That's even better.
Yeah, then I can say what I really feel.
All right. Bye, guys.
Okay, I think we can continue this discussion on the mailing list, or please attend platform working group meetings, and then we continue discussion this one.
Okay.
Thanks, everybody.
Thank
it was a great
I have
discussion.
this standard SVPBMT. How long we could merge into the Linux? I mean the standard SVPBMT.
I think Go will be kicked out in like 30 seconds. So
right, you will.
Yeah. Let's discuss in the mailing list.
Okay.
Okay. Thanks, everybody.
Bye.
Bye.
Okay, do we have Sahil? I made you presenter. If you have anything to upload to share, you have to use the plus button on the bottom left.
Okay. Yeah, I'll try to plus button where?
If you look at the below current presentation on the left, there's a plus button. If you click on that, it takes you to something that says Manage Presentations. And in that screen, you can upload anything you want for the BOF.
So just where do I choose the presentation from? Like if I have something on my local machine?
Yeah, any PDF file on the local machine can be uploaded, or you can try a screen share. It's been working with most browsers, but there are a few browsers that don't like it.
Okay. Yeah, I found a link to upload my local presentation. I'll try that.
Okay, and if you want to unmute your video as well, so people can actually see you.
Just a sec.
Okay, we've got the presentation.
Great.
Thank you.
So I'll just give a couple of minutes. I don't know if everyone who wanted to attend this is there yet, but this is a follow-up to yesterday's presentation on user interrupts. and there was a bunch of interest on doing a follow-up, going through the hardware architecture and how user interrupts works underneath. So today, at least I'm planning to go through like a quick preview of what we discussed yesterday, like a couple of minutes or 5 minutes, and then deep dive into how user interrupts are implemented at the hardware level. And then we can discuss any opens, any questions. And I am hoping this to be an interactive session, and so feel free to interrupt me or like ask any questions. I'll try to answer them if they're posted on the chat. Okay, so let's get started. So user interrupts, at least what we discussed yesterday was user interrupts is really a really fast way to signal. So today, today all the communication, like inter-process communication, IO event, delivery, they all happen through the kernel. The idea with user interrupts is deliver events directly to user space. So bypass the kernel and pretty much reach directly to the user, and this helps reduce latency. It's super fast and it's efficient. This feature is coming up in Sapphire Rapids on an x86 processor called Sapphire Rapids from Intel. And overall, there are multiple sources of user interrupts that can that can generate interrupts. One of them is a user-to-user IPC. It's called SendUIPI, which allows one application in user mode to send an API to another application running in user space to without any intervention from the kernel. So you just execute an instruction, and you pretty much receive a notification on the other process. And there are other forms of user interrupts. Like one is where you could have a kernel source generate an interrupt that gets delivered to the user directly. The patches for this are still in development, but that is also possible with the Sapphire Rapids platform that I discussed. Now, in future, we envision to have other sources of interrupts like devices or any other external source that could generate an interrupt, and it gets directly delivered to the application. This technology is still being defined, and it would come up in the future, sometime in the future. So let me take a pause here and ask if there are any questions, or if people have any interest in what comes next. Otherwise, I can go ahead with the plan that I mentioned. Okay, I'm checking if there are questions on the chat. If not, then I can go ahead with how user interrupts are implemented on the hardware side. So for user interrupts, these are, I'll try to go through the hardware architecture and what are the basic architectural features which the OS needs to take care of, right? And so one is the there are a bunch of new x86 instructions. The one that I discussed earlier was SendUIPI. This is a user space instruction. It takes in a parameter. I'll go into the details of what this parameter is later, but it pretty much allows you to generate an interrupt on one process and generate a notification from one process, and it gets delivered to the other one. UIRET, it's a user interrupt return handler. What this does is it allows, say, if you have, similar to signal handlers, if you have a user interrupt that gets generated. So let me actually share the sample that we went over yesterday. And so over here, this sample, what it does is you have a user interrupt handler. This is similar to a signal handler that would be called whenever you have a user interrupt delivered to the application. And so as part of this user interrupt handler, you have this interrupt attribute that is recognized by GCC 11. And so as part of this attribute, GCC saves all the registers that you need to save, like all the general purpose registers. And then when you're done processing the interrupt handler, you call UIRET, which is also automatically inserted by GCC. So applications don't need to worry about it. And when you call UIRET, the control would return back to where the application was interrupted. And so you can just continue executing where you were previously. So this is the send UIPI instruction that I was talking about. This allows you to send the interrupt. Then there are a bunch of instructions called which help you manipulate the UIF flag. The UIF flag is called the user interrupt flag, and it lets you enable and disable interrupts or test whether interrupts are enabled or disabled. And so the instructions for it are similar to the x86 CLI instructions. It's STUI and CLUI and TestUI, which allow you to disable interrupts. So let's say if you're running some critical section, if this application wants to run some critical section and it doesn't want to get interrupted, it would call CLUI. And once it's done processing the critical section, it would call STUI, and then it would go ahead, continue. That would enable interrupts, and it can get these interrupts delivered at a later point. So these are the x86 instructions. Any questions here? The next thing I'm planning to talk about is the, so actually there are a couple of, there's one question over here. Oh, actually there are a couple of questions. So one question from Jason is there any standardization work we can see for other sources? So, for the source of interrupts right now, we're thinking it could be devices, but we haven't narrowed down what exactly how it would look like. And so it would still take some time for us to put out something publicly. But on the receiver side, we think they would still look the same. So the receiver infrastructure is all common, and the way applications receive interrupts wouldn't change with what the source of interrupts is. And at the software side, what we were thinking is we would have an FT that the receiver would create as part of registering itself as a receiver. So when you create when you register yourself, you create an FT, and now you use this FT as an authentication mechanism for anyone to generate an interrupt for you. And so that would mean you can send this FT to another user space task. You could possibly send it to a kernel agent like IOU ring, or you could send it to a device driver, and then it can do the plumbing underneath to get connected to the so actually the device driver itself wouldn't have to do the plumbing, but we would have some in-kernel API that would do the plumbing for the device driver, and so the device would just try to connect to that, and then eventually interrupts would be delivered to the application. Does that? I know it doesn't answer your question fully, but do you have any other questions, Jason? I would take it as a no. So one question from John is how the CPU knows the right processes and running in order to deliver them. Yeah, so that I would go over that. I would go through the step where from the exact point the send UIPI instruction gets executed to the point the interrupt gets delivered, and how what things get updated and how we get the interrupt delivered. So there is a question from Kim about, have you considered adding support to an existing IPC call and putting the user interrupt instructions in VDSO? So we haven't looked at VDSO, but we did look at considering an existing IPC system call. I forgot to say. So if you can download the slides, then you should be able to see this link where I've discussed where it is the first RFC patches that I've sent out probably last week, and so this is where you can see, like, I tried to compare it with signals and event FT, and whether it's trying to see if we can fit this in. The main issue with fitting it with existing mechanisms was that these user interrupts depend on the hardware, and fitting like having a hardware abstraction and having a purely OS abstraction together was turning out to be a little bit complicated. So I have listed the reasons why we didn't do it, but overall it was just it would be confusing for the user who's already used to some sort of guarantees from the existing IPC mechanism to use user interrupt FT in that direction. Another question from Claudia is, in case of x86, can a task interrupt any other task? So in case of denial of service, I do talk about denial of service in the RPC as well. And so the permission to interrupt a task is given by the receiver. So idea here is if the receiver should share this only with trusted processes. Like you can't use this, you can't share the user interrupt FT, or I wouldn't recommend sharing the user interrupt FT with a device, I mean, I wouldn't recommend sharing a user interrupt FT with a task that you wouldn't trust, because denial of service is definitely possible. Maybe one task might not be able to do it, but if you have like that same task that does multiple, like it does a multiple copy of this FD, and it tries, all of them try to send interrupts at the same time, it would be possible to do a denial of service. And so this is only between processes, between tasks that are of the same address space, so within the same process, or across processes where you really trust the task. Okay, so the next one I have is these are this is how the hardware relates to the state of the task, right? So this is what connects with a user space task to how hardware sees it. So these are a bunch of MSRs, 6 namely, and they store the state. So this is what the hardware would refer when a particular task is running, about seeing where to store the task for that, to store the interrupts for the task, to have the handler address stored for the task. If the task has requested for a stack adjustment, then how much should the stack be adjusted? Do we need an alternate stack? And that's where we would put this, the kernel would put the information here. UPID, these are the pointers to the UPID and UITT structs. I would discuss them in the next slide. But all of these are per thread task, and the kernel would save them as part of context switch. So each task would have its own set of values for these MSRs, and the kernel would save and restore them at every context switch the task goes through. And over here, the handler and all of that are specific to that same task. So right now, the way we've designed it in the first RFC is these are all unique to each task. So when you even if you have tasks of the same process, all of these values wouldn't carry forward to the other process, to the other task. They would need to be like, that task would have to register itself, register a handler for itself, and register different addresses to get this to get these populated. So now this is the main crux of the user interrupt delivery, right? And there are two main architectural structures that we have. Both of these are in-memory structures. They would be allocated by the kernel. One is called the UPID. This is the user posted interrupt descriptor. What this stores is this stores what pending interrupts are there, what is the existing notification state and the routing information. So before we go here, let me describe how this overall instruction works. So send UIPI overall is a posted instruction. So it's really an asynchronous instruction where a sender, it executes send UIPI and then it can go on continuing. So this instruction wouldn't block and you would continue doing something, whatever you want after this. Now the interrupt delivery would happen, could happen immediately if the receiving task is running on another CPU. If the task is not running, then the interrupt delivery would happen at a later time. And even if the task is running, it could have interrupts disabled using the CLUI instruction that I mentioned. And so still the interrupt wouldn't be delivered at that time. And so this is truly a posted mechanism where you post the interrupt and the receiver receives it at a different time. And so these are the structures that are used for that. And so when you actually execute send UIPI instruction, what the hardware does, what the instruction does, it updates a bit in this memory structure to say that, okay, this is the interrupt that I need to deliver. It's a memory structure, and so this would be able to be seen by the receiver as well when we context switch the receiver back. And so now it saved this in memory, and now it tries, there is a bit called the SN bit and the ON bit. These two bits signify whether there is an ongoing notification for this task, or if the task is context switched out and we are suppressing notifications at this point. So after saving the interrupt vector, or after saving the interrupt in this bit, in this 64-bit memory space, the hardware would check the SN and the ON bit and see whether an actual interrupt needs to be generated for the receiver. Now, let's assume the case where the SN is 0. So we are not suppressing notification and we want to deliver an interrupt. So what we would do is, in that case, then generate, so what this UPID structure also holds is where this task is currently running. So it would hold the CPU, the physical destination. Right now, this is x86 specific, so it would hold the x86 specific destination CPU in the UPID structure. And this structure would be updated every time the task context switches. So now you say if you have a process running on CPU 0 and it moves to CPU 1, during context switch, the kernel would update that structure. And so this routing information is updated in the UPID structure. And so anytime a sender executes send UIPI, it would refer this, the hardware would do this automatically, like the application doesn't need to do it, but it would refer the routing information and it would send the physical IPI to the CPU that was actually running, that was running the task, that was the intended receiver. Now, so how does the sender do this, right? This is the UPID is a receiver side structure, which is updated by the sender and referenced by the receiver. And now you have another structure called the UITT. The UITT is a sender side structure. And so the MSR that I talked about, the I32 UITT MSR, it points to the user interrupt target table. And this table holds a bunch. So every time a sender registers itself as a sender, it would get a new entry added to this table. And each of these entries point to a specific receiver and a specific vector within that receiver. I apologize for this. My presentation tool misrouted this, but this is actually supposed to go from here. It is supposed to go through interrupt vector Y, and it's supposed to reach receiver task A UPID A. And so what this does is you have a send UIPI instruction. So now let's say the sender executed send UIPI 2. So if it executes send UIPI 2, the hardware would refer the UITT entry. The UITT entry would have the UPID pointer for the receiver task. So it would look at the SN, ON bit, the routing information, and then generate a physical interrupt. that would eventually be routed and delivered to the CPU that was running task A. Now over here, the CPU, based on the MSRs that we have programmed, it would recognize that this is a user interrupt. And so instead of generating a kernel interrupt, it would deliver the interrupt to the user. And so it would load the handler address that we had programmed, and it would deliver the interrupt to the user. So that is pretty much how the send UIPI instruction works. I have another slide to talk about how the interrupt delivery happens on the receiver side, but this is how we the send UIPI from the sender side. This is how we send the interrupt to the receiver. And now on the receiver side, I can talk about how we deliver the interrupt on the receiver. But any questions here? I know I went over this pretty quickly since we just have a half an hour slot. Feel free to speak on the mic or post your questions over chat. I think Lorenzo is typing. I'm waiting to see what he's typing. If not, then I would go to the next slide. So the question is, when is the IRQ delivered if the receiver task is not running? So if the receiver task is not running, then the IRQ would be delivered when the task gets scheduled back. Now, it depends on why the task was scheduled out. Say if the task got scheduled out just because it ran out of its time quota, because of the schedule, because it ran for a long time and the scheduler just switched it out, then it would have to wait its turn. And when it gets scheduled back, the kernel would look at whether there are any pending interrupts in the UPID structure, and then it would deliver. Then it would. So right now we do a self IPI, but there are other mechanisms to trigger a user interrupt as well. And so the kernel would pretty much update the structures, and when the task becomes running again, so when it moves to ring 3, it would get the IRQ delivered. Now, let's say the task was blocked in the kernel. It did a blocking system call and it was blocked in the kernel. Then what we would do is the idea is the kernel would actually interrupt the blocking syscall. And so the blocking system call would get interrupted. The task would receive an e-inter similar to a signal handler, and we would deliver the user interrupt notification at that point. I do have an open over here where we're not sure whether we want to interrupt every blocking syscall or do we want to have a special syscall that just blocks for user interrupts. Right now in the RFC, I have a user interrupt wait system call that allows an application to block and wait for user interrupts. But like if you want to have a behavior similar to signals where like a sleep or a read or a epoll, you want to break out of a epoll, then we would we would have to do additional plumbing. But it is definitely possible architecture hardware wise. Thanks, James. Yeah, that's all. So the question from Jason is the IRQ delivered to a single thread or any thread in a process? So the way it is designed right now, it would be delivered to the thread that created the FT. Now, since this is hardware MSRs, it would be very tricky to figure out like the hardware to figure out which threads are running and out of the process, and be able to deliver it to a particular thread that is actually running, right? And so over here, the idea is it's mainly for a point-to-point communication between threads, where one thread generates a send UIP and it's targeted for a specific thread, and only that thread would be able to receive that interrupt. I've described, so if you look at the RFC, I've described how this compares with signal handlers and why we couldn't expand signal handlers to this. And one of the reasons is signal delivery is process directed. where any thread in a process could be running and it could receive the interrupt. But this is user interrupts in its current form is single threaded, where you have to have the thread running that is it's targeted for. Now, this is the second part where we talk about how user interrupt delivery works. So remember, I talked about how the sender task executes senduipi2. So the first step we do is update the UPID. So at the sender side, we update the UPID. The second step that happens is generate the notification vector interrupt. And this would happen depending on whether the receiver is running or not, and that is updated by the kernel into the UPID struct. And so if the receiver is running, we generate a notification interrupt. When this notification interrupt gets delivered on the receiving CPU, we recognize the interrupt as a user interrupt, move the pending interrupt from the memory structure to the hardware MSR. So this is where we actually detect the interrupt, right? Because up till now, the interrupt was only posted in a memory descriptor, and now we move it to a interrupt descriptor, move it actually to the MSR. And this is where we detect the interrupt. And now the delivery of the interrupt happens if the application has enabled interrupts, right? So if it has executed XTUI, then we would push the vector onto the stack, the vector that was generated as registered as part of the FT creation. We push it onto the stack. This helps the application recognize which sender is it receiving this event from. So we have 64 vectors, and this is the vector that it is receiving. Based on this vector, it can determine which is the sender that sent it. And then it invokes the handler. And so this is how the handler invocation works, right? Where you have the UIRR, and you move it to from the UIRR, you call the handler. The handler address is stored in the i32 handler MSR. So the hardware switches to the handler MSR, to the address pointed by the handler MSR, and then you have the vector that is delivered to the hardware, and then by the hardware to the application, and then it does a UI ret, and you return from the syscall. So that's all that I had. I know the time is up. Is there someone else following this, or can we hang on over here for a few minutes if people want to continue here?
Yeah, technically there's nobody following. The keynote is in 30 minutes, so you can have another 10 to 15 minutes if you really want.
Okay. I don't know. I don't have much to present. I just wanted to give time for questions. If people have questions, then we might continue. Otherwise, we can call it a session.
So if people do have questions, we'll get through them faster if they actually ask over audio.
Yeah, I was hoping that too, but feels like a shy audience. They prefer to ask it through a chat. Yeah, I don't have anything after this. This is all that I wanted to discuss about how the interrupts get delivered. I had to go through this quickly, so please feel free to ask questions if you have. Or you can go through, if you want to read up, then you can read up the patches that I have, and in that I have links for the GitHub repo where these patches are stored, and we have additional samples and tests that run on this. There is also a link to the hardware specification, and you can always reach out to me at the email address. The email address is also there in the slide, and it is also there in the patch series. So I see Lorenzo typing in, so I'll just wait if he wants a question. Okay, he'll probably reach out offline. So I don't think we have much. Thanks, James, for letting me continue for a few minutes. That's all that I have.
Okay, you're welcome, and thanks for coming. And I suppose I should change the slides to thank all the sponsors if you want to stay on for that. That didn't work. Okay, so we begin thanking the sponsors with Facebook, the diamond sponsor. And we move on to IBM as the platinum sponsor, whom I work for. We have 2 gold sponsors, which are ARM and Microsoft. And we have 3 silver sponsors, AWS, Amazon, Netflix, and Red Hat. The speaker gift you got, which I should have, but I forgot, the little FIDO2 token was provided by Collabora. And VMware will provide the t-shirts, assuming you're lucky enough to be one of the first 200 people who fills in the survey that will be presented at the keynote. And after that, and the Linux Foundation, who provided conference services to us. And just a reminder of the anti-harassment policy, which you've been reminded about quite a lot now. If there are any concerns about execution or the way people are reacting on this chat or the video or anything, please either send an email to contact@linuxplumbersconf.org or to join the moderator's room on the Matrix chat to raise the concern. Email will be anonymous. Obviously, the moderator's room is visible to anybody who joins it. And with that, I suppose I should just remind you that there will be a keynote in 25 minutes. That's going to be at 1900 UTC, if I've got my time conversions correct. And so we hope to see you all there. Thanks very much, everybody. See you in about 25 minutes.
You are currently the only person in this conference.